All right. This is all we're going to get for an intro, just this song. And then I got to start because I got to finish this code. This code's been bugging me, so I need to work on it. I worked on it a little bit yesterday. Got those quadratic equations all, not quadratic, whatever, the polynomial equations all set up. So just going to hit the ground running. We're going to get this microcontroller working. It's not going to run the first time. There's going to be all kinds of syntax errors and stuff like that. That's just what happens with this sort of thing, right? It just happens. It's just going to happen. That's a little better. Okay, let's see. Sorry, you guys on YouTube, you don't get the music. Oh, the song's over. My predictions are true. Wait a minute, don't keep going. Let's pause it. Let's just get to work. We're just going to get to work. There's nobody here, but they're going to see microcontroller code as the first thing. Oh, there's the YouTube stuff. Let's move that all the way over to where I can monitor it. And then I need to have Twitch open so that I can see that I have viewer. I have viewer. Both of my viewers aren't here yet. My title I did not update in time. I hope the VOD does not have the old title in place. The new title is Modular Synth, VCO still, I must finish this arduino code. And it thinks that arduino is spelled wrong. Probably thinks I should capitalize it. Yeah, here's some of the work that I've been doing. These equations are huge, and they're modular, and they seem modular, but it's like, maybe I don't need all this stuff in there. I was thinking that maybe I would just need a function that does, like, the first part of it, just does that, and then I would run section by section of the calculations, because they're all added together, right? Some of them are, this is not inside of the nested sines, but everything else, like these, are nested sine waves. So it's like sine of this plus sine of this plus sine of this plus sine of the whole deal plus this plus it. I tried to break it down, and what I ended up with, and this one is the original code. I have the original code, and then I have the one that I'm working on, which is test. No, not test. It's not test. It's, oh God, which one? The framework. So VCO frame, unfortunately, is morphed into a much larger program. And this one, I have not given this one a function yet. But what I ended up making is an FM modulator, and then an FM modulator, because this one makes wavetable too. Void modulator. So, where were we with this? Oh my God, this is complicated. Oh yeah, switch mode squad. Don't make that, jeez. And then all these cases are part of that. Done. Switch waveform. This one needs a bracket at the end. Oh yeah, we don't do, it's not mode, it's waveform. Hey, Silly Russell, 77 months. We were listening to later alligator music at the beginning. I just played the one good swing song from this this extremely cute and wonderful game, Celia. You should look at this game. It's amazing. Later alligator, hand animated. It's a beautiful thing. But yeah, anyway, I started like immediately. So there's no intro at all. We're getting right into the programming, and I need to read through this code and figure out what exactly it's doing. I'm starting to get Haji well. I'm starting to understand how he was doing things. I don't necessarily agree with the methodology, though, and I think it needs a little bit of revision in terms of functions, sub-functions, and sub-sub-functions, you know? But I don't know. It's probably not good practice to do stuff like this, because I left all of these coefficients as variables. What's that? No intro? Yeah, I just started right away to one viewer. Yep. I even showed the Twitch window. You're viewer number 2. I guess we've gotten a couple people in here since then, but we're back to the OG days of me just streaming to nobody because programming is not all that popular, let's be honest. All you programmers have gotten the back to office notices and are now commuting again instead of sitting in front of your computers watching some old guy struggle. Which, let's be honest, the struggle's the fun part. That's the fun part. That's why we don't do victory laps often. Okay, so what I'm doing with this is we have these infernal giant equations that dictate how this thing they dictate, like dick potato. Oh, I don't have it open anymore. They're like nested sine wave equations that dictate how the wobbliness happens within the synthesizer, and they're dependent on mode. There are different equations for them, but they all seem very similar to one another. And so the programmer in me, I got that dog in me, that programmer in me said, hey, this doesn't seem right. Maybe you should rewrite them to be functions. And I did it, and it kind of makes these switch cases a little bit more digestible, I guess. But when you get into how these things are being like put together, I have default modes. I've got this weird ass program right here that I wrote yesterday, and it is a lot of math and it's a lot of weird stuff. And if you want to go in and edit the equations, you have to go in and like manually change a number or two, and it's just a little sloppy. The way Hajiwo did it is they were all individual functions that were all just programmed similarly. But for me, it actually starts on the outside and works its way in using if statements. So if you declare a mod D, if it is not 0, then mod E and mod D are calculated and stored back inside of an integer. And maybe these need to be floats if I'm going to do that, but they're stored back inside of an integer at mod D, and then if mod C is declared, then we calculate mod C and we store that in mod C. Mod B is stored in mod B, but actually, don't these need... Yeah, here, mod C is rolled into mod B, and then mod B is rolled into mod A, and then mod A is rolled into the wavetable 2, mod 2 wavetable equation. And one of them is halved and one of them isn't. It depends on whether FM8, which is just the initial Boolean, is set. So I have all of these different modes with one initial Boolean set, and all these programming things just doing... Oh, God, it's so weird. Zurcher positive. I don't know what the fuck that is. I had to look up the last meme about Polish people following beavers around and laughing. Zurcher squash? How to Zurcher squat? Wait a minute. Oh, that's the Russian squat, isn't it? No, the Zurcher squat. It's like an exercise. I don't know what... How do you guys feel about Zurcher squats? Reddit's weightlifting. I think it has to do with the position in the hole. Huh? The Zurcher allows you to sit deeper and the glutes would be stretched. Okay, that's enough of that. That's rotting my brain already. So yeah, thank you for the 77 months, by the way. Kind of silly, he was doing some Amiga intro streaming because a friend of mine wanted to see the Settlers intro. Ah. Went from 1 viewer to 70. Oh, you got rated by 2 other Amiga streamers. That seems like a tight-knit group, huh? I had to explain them I'm not a streamer and I don't really do this stuff. That's awesome, though. I don't positive or negative on the Zurcher thing is let's just leave that up to the content of my character and the attitude by which I perform this stream, huh? I guess. Let's do a commented guide on how to use FM Modu. So case 0 FM Modu, and then the coefficients are FM Modu is a much simpler one because those are simpler equations. So it's int mod A, int mod B, int A, int B, bool 8, and then I guess the rest of those won't line up if I call it a bool, though. Ten bags of groceries in the nooks of your elbows doing this. No, you gotta use your fingers, man. That's what it's all about. Each finger, you know, a couple grocery bags per finger. You cut off all circulation. You carry everything in one trip. That's the way of things. That's just how it's got to be. So yeah, I made these. I don't really know if they're going to be that useful. I mean, FM Modu is fine. It's just that whether or not I should have taken the commonality of all of these things, the mod over 128 times sine 2 pi m pi times mod e times I over another number. and busted that out into a function, so it's a little clearer how these things are being calculated. But I'm going to stick with this for now. We're just going to see what the hell happens when I run this. We need to figure out where the hell this FM modu, or the modulator, gets run. And I believe that it's up with FM, but again, we've got to go back into this and just figure out what the hell's going on. Then we need to build an LED engine. I need something to move entries of a table and blank out the non-entries of a table and run the LEDs so that if there's a queue of things that need to happen, we will get the appropriate action out of the LEDs. So if you push the button once, it'll blink once and then go dormant. But if you jam the button a bunch, if you go up to mode 4, you punch it 4 times, it'll go 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, right? So that needs to happen. And I think it's going to happen wherever we activate. Well, I don't know. Should I do it in this case switch and then have the LED do stuff at the end here? Because that's where you would have it, but then I'd have to repeat it for each one. So for mode, we're going to have it do the mode stuff. All right. This is going to get complicated. So let's check out what the hell's going on here. So mod switch wavefold AM on table set, but for some reason for FM we're not table setting, and I probably think we should do that. I'll just put a question mark there. All right, let's go back and let's just see where we are with this. So we start out, I'm not going to worry about the variables and stuff. I'm just going to go through this code and try to get this running. I really want to get this running. I want to get this code done. I'm trying to get everything done within this code. There are things that I expect this to do, and I guess we'll endeavor forth to get this done so that we actually have something cool to look at today instead of just me looking at code like this. And I tried to get ahead of it, but I also did 4 uploads yesterday, so I was feeling good. I got a lot done. I made some good thumbnails. That was not necessarily the best thumbnail, but it's okay. I was what's the clown's name? Fucking clown name. But Dr. Patch Adams, what the fuck? Pagliacci. But Doctor, I'm Pagliacci. Pagliacci? That doesn't seem right. Whatever. Okay, so let's get going on this thing. So we have our pin setup here. We have the settings, which aren't all of the settings. There's some calculation settings in there. Pagliacci. Okay. Chi. We're using the Seed Studio Zao. We got Pagliacci. I don't know how to pronounce all of these weird letters and stuff. Frequency size, octave scale, etc., etc., etc. The one thing I don't have is the frequency of the microcontroller. And that might actually just be something like clock frequency that I can get through some kind of Arduino thing that's already set. So we'll ignore it for now, and hopefully it'll never become a problem. Never, never. Okay, coming through here, we set up our variables. So we got our analogs, we got our mode variables, we got our frequency variables, got our PWM stuff. There probably will then be LED stuff, so I'm just going to make that right now, LED stuff. And then down here, we set up the debouncer so that our button doesn't press 500 times. We have predictable behavior with a nice little debouncer on there. I forgot to say hi to Fatanon. Hello. Okay, so moving on, we go to the setup. We set up our pins as input pull-ups for the inputs. For the other inputs, we just set them as regular, I guess. The mod in and CV in are knobs, so they don't need an input pull-up. They just get regular old input. Pin mode, LED output, audio output, 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 output. It's PWM actually, but it's audio. We're calling it audio out. Then we need to read in waveform number, which we will get from the EEPROM. EEPROM.get prom-L waveform. We're going to read that in from non-memory. There's nothing set in there on initial boot. So I don't know if I should take that prom location and give it a value, or maybe just the first time. I mean, if it's above 7, it'll start at the beginning again. So we'll get a weird value, but it'll reset it to 0 as soon as this runs the first time. So even if it is 0, I guess it'll just stay at 0. And if it's in the negatives, I don't know if we can do that. They used a Raspberry Pi Pico and made a 24-channel logic analyzer. That's pretty cool. That's a nice project. What's their software like, though? That's the thing. Then we do PWM setup. PWM setup is just a big, oops, wait a minute. I hit shift and it scrolled over. PWM setup is just a big mess of PWM things that happen. So on the PWM setup, GPIO set functions. So we set the audio out to be a PWM out. We set our slice number, PWM GPIO, to slice number of audio out being where the PWM is going. We set that slice number so that we can reference 0 to 1024 slices. That's the slices of the PWM. That's how long it holds it high and low, and how much resolution you have in the width of the pulse width. Because what we're doing essentially with the pulse width is we're playing a game of Flappy Bird with our waveform. So that pulse is coming out very, very quickly, and as we add energy to it, it goes up, and as we subtract energy from it or not give it enough energy, it then falls down. We're taking an average of that. There's a couple other encoding schemes, but that's the sort of the wave. That's not wave folding. That's just the encoding scheme of the actual physical hardware. So yeah, clear the IRQ because we need that interrupt request. That is going to trigger the thing that sets by the frequency referencing a table. So we make a table of values for the frequency that will directly control the PWM. That's done by an equation. And when we have that table of values, we can then very quickly reference them and output the appropriate amount of PWM to affect the signal, because we're going to be affecting change on this line very, very quickly indeed. So we need that interrupt in order to get us to wrap back around and assign a new PWM amount, because these are fractions of audio waveforms. These are slices of audio waveforms that we're referencing. This is microcontroller shit. Things are happening way faster than you think they are. Yeah, I'll check that out later. People seem to like ignore the fact that I'm like about to go on. Like a friend of mine was like, here's this cursed like gun that somebody found and did a review of, and he posted that to me like 5 minutes before I went online. Like, what am I gonna do? I don't want that in my head while I'm streaming. Like, I don't want that in my head. I'm not a gun nut. So clear the IRQ, set the IRQ to enabled. Yeah, my streaming schedule is incredibly erratic. I send chat into a panic if I start at 12:36. So we set that up, and we set the PWM IRQ wrap to be enabled. So that's going to come back. Is this real chat? No, this is I'm pre-recorded, and the dead internet theory is correct. None of us actually exist. We're all just AIs that are deep beneath the crust of the Earth's surface. Willow just got back from the groomers yesterday, and not like that kind of, no, like, I mean the dog groomer, the dog groomer. Not that they groomed dog. She got a haircut. She got a haircut, more than one haircut, and she's got a super bubbly butt now, and she's super soft, and she smells like dog shampoo. But she's looking pretty fly. She's very, very cute. I posted a picture in the Discord, but I hear barking up there. Nah, you guys definitely said it. You said it right there in chat, right there. PWM set clock division, slice number, PWM CDIV. I guess that's built into the PWM thing that I'm using. It's some RP2040 direct control of PWM kind of Jiminy John. I had a burger for lunch, which means I'm going to be irpy, and I'm going to try not to be too irpy on the mic. I hate the irpiness that happens during my time slot, because I try to eat a lunch to get some food in me, but it always causes irping. Okay, set wrap, slice number, PWM wrap. Okay, PWM set enabled, so that gives us our PWM wave. That just sets it all up. So this is just a big ugly block of code related to the RP2040 PWM library, right? I've left little comments around there, but this is RP2040 PWM library. Do you wash down your burger with phosphoric acid? I think my stomach handles that. Okay, so we've done that. We've set up PWM. We're all the way back up here now. So we've run PWM setup. Oh wait, table set and table setup. So what table set and table setup are doing are making the initial tables and then creating something. Let's go check out what table set does, because we're going to be referencing that later. I don't know if there's that much phosphoric acid in sody pop. I guess it's a little acidic. Table set. So table set, depending on where the switches are located, runs either the wave folder or the AM, I guess. So wavefold and AM are two different routines, and I put them in here like this to make this more simple. The simple jumps in, what is it? Oh, objective. In Objective-C, using the objects to organize things really helps, because you get an overview of what something is doing. Oh, this does all that? What does it do specifically? And then you'd make another jump to the next piece. I don't know chemistry. Like, you can, if you wanna gotcha me, just talk about chemistry. That's all you got to do. I'm not hard to gotcha. So depending on where the mode switch is, so it's 1, 2, or 3. And I probably should make it do the FM stuff here, because table set is directly referencing the waveform mode, and, well, table set specifically is not. It's looking at where the switch is, and that gives you wave folding, FM, or AM. Stomach acid is 2, only a 10 times difference. It really does help digest food if you drink acidic soda like cola. Why would they want to help you digest the food? I guess the whole point of the food is to dry you out with salt so that you want the soda, and then you sell the soda at a huge margin. That used to be the conspiracy theory. Now everything's just expensive. So we're going to either wavefold or AM initially. This is right on first boot, so there's no tables made or anything like that. Do we have the variables for those set up yet? Yeah, we set up the variables up here. So we got the variables, like, you know, cordoned off for the processor to use. Now we set up these initial tables. So table set is the initial one we run. Let's say we're in wave folding mode, so we go to wave fold now. So down here we have wave fold, and when wave fold runs, it looks at what the waveform, aka mode, is set to, right? Because there's 7 of them. What's up, poopy doodle? Oh, wait, poopsie doodle. There we go. I was reading it on my OBS monitor, which is very small. Okay, so we run any of these. So let's just say we have a saw wave. Let's say we're on case 0 and we're in wave folding mode. We go to saw, and saw is its own little thing. For integer I is equal to 0 to 256. I plus plus. So we're iterating through a 0 to 256 table, wave table of I. So we're setting the initial wave table to be the number 0 to 256 times 4, but then subtracting it from 512, and that's just going to give us a saw wave. That's it. That's all it does. Yeah, Listexia. Listexia gets me all the time. That's how we make a saw wave. So our table's loaded up, our wave table's loaded up with a saw wave. Well, what happens next? Well, next we jump out of the table, where is it? Table setter. So we probably should have FM in here, but we'll keep an eye out for that, because I need to figure out how the rest of this program works. Like, so anyway, we've got a saw wave and wave table. We're out of this, and now we go to table setup, which is a little odd. So table setup is down here. And let's uncomment this. Table setup. I is equal to 0, I is less than octave resolution, I plus plus. The frequency table, since we've just set wavefold, why do we have a different frequency table? F0 times power of 2 to the, it's basically 2 to the number of octaves times I over the octave resolution. And we are taking, so that's just scaling it exponentially, isn't it? Taking it as a ratio of F0, something like that. Saw wave has the direct down. Sawtooth. I guess it's just triangle wave or something. What's the other one? Saw wave, I mean, it can go, I don't know. You look up waves. So these are from the original one, and I'm not entirely sure what's happening here. We have frequency table of I, which is I to the octave resolution, which would be the PWM length, right? Or octave resolution is octres 1230. So this is apparently the maximum resolution that we can have for the PWM signal. So 0 to 1230, dictated by a 0 to 256 thing, but 0 to 1230. So 1230 is 6 octaves. And so with the frequencies in those 6 octaves, we are setting up, what are we setting up? We've already set up a wave table of I, but now we are on, so this is setting up, I think, the base frequency table. Frequency table is equal to F0, and F0 is our initial oscillator frequency, times power 2 to the number of octave resolution. So this would be setting up a wave for everything to follow, like a voltage wave or something like that. I is equal to 0 to frequency size minus octave resolution, I plus plus, and then it's I plus the octave resolution is equal to the number of octaves, which is 6. So it's setting a 0 to 6 volt wave, basically, and then here it sets up all of those, I guess all of the other half of it to be 6. This is just what Hajiwo's code said to do, and I don't necessarily understand this entirely. Maybe this will help us understand it a little bit. That was that Wall Street guy. Man, imagine a quarter of your lifetime you got to spend sitting on the sidelines because you did some really shitty financial stuff. Triangle wave. Yeah, okay. So I just, for some reason, my brain blocked triangle wave. I'm trying to, okay, so we're trying to figure out exactly what this thing is doing. There's a table, like an octave select here. And so with octave select, this is essentially what we were doing, only we took voct pow and we turned that into an equation, because having a giant table, this huge table, is really kind of not necessary. We can make the microcontroller calculate this once, and then we will have frequency table of I. But what else are we doing with freq table? We're using it 4 times. Well, that's the initial octave select. So we are setting entries that are plus 1230. So from 1230 to 2048, we are setting the entries as 6. And then the only other time it's used is after, okay, so this is in the loop. This is the main loop. In our loop, we then take our analog reads, map them to a set of values, and then we take the frequency. Okay, so what this table represents is what frequency our oscillator's at. We have a mode, and then we have a frequency. Well, we have a modulation mode, we have a frequency, and then we have the modifier. So there's 3 things, and they're very confusing. The base frequency that we've set, that is controlled by a knob or by a CV voltage coming in. We have the modulation scheme that's set by the switch. We have an octave that's set by the other switch. Sorry, we have more stuff. We have an octave that's set by the other switch. And then we have a mode that is set by the button. And that mode is a type of waveform. So you have a frequency, modifier, octave, waveform type. 4 things that are going into this VCO's output. So right now we've set up a table of values that represent the range of frequency. So this is the set of values that dictate potato the output frequency over the, I'm going to do another line, various octaves, modes, modifiers, modes, and waveforms. Whew. A fifth variable to add harmonics. No! That would be a filter. A filter would do that. And we're just a VCO. A lot of VCOs do incorporate filters, though. I'm going to get a glass of water. Speaking of acid, I'm going to have a glass of water. I need a clean glass. Okay? That's too high of an order. Did Fadadon, like, drop in and then just fucking explode and leave? I think he did. I think he did a chat terrorism, and he just came in, exploded, and then left. There's one comment, and it almost triggers me, and then he just scarpers. All right, let's get a glass of water. This is lovely sink water, because I didn't have time to go upstairs and get the filter and all that. I should get one of those little filters down here, huh? All right, so it's becoming a little bit more clear what this thing is doing. And I think it probably should be doing all of this stuff a little bit more, like, modularly, I guess. But yeah, this makes a set of values that dictate the output frequency over the various octaves, modifier, modes, and waveforms. And it does this once. That's all it needs. I'll often get the glass of water and then never drink it. Can't have that. So yeah, that's what that does. So now we have a table that represents all of the different frequencies and the resolutions that we can read. God, that is complicated. So we're still getting through setup. So what we've done is we've set an output we've set our frequency table and we've set our modulation table. So this is through the PWM. So table set, let's go back to table set. Bit handler, do wave, modulator. Table set. Nope. Find. So what does that do? It sets up, populates mod2 wavetable for output. Uses mod switch. So that does that, and it probably should do it universally. It probably shouldn't be doing it like this, because we're reading modes somewhere else as well. But we'll get back to that. We'll get back to that when we get to the main part of the code. Plenty of inline filters at the top for the sync for the $50 range. You mean for VCO? So I could filter my VCO? I know, there's cheap, I could get a cheap filter to filter the water here. I'd rather have one of the jug style ones. That would just work better for how things are done around here. I just have to go to the sink and fill it up. But again, that's another thing. It's just another thing to be around here. Hydration is important, but the sink is over there and our water doesn't taste too bad. So yeah, now we've set up all of our tables and we're ready for output, right? So we set up all those tables, then we set up PWM. PWM is, I don't think it's referencing anything. I'm not sure. If the table's set to one of the mod2 wavetables, I guess it would work. But if we're set to FM, then it's not doing anything. So actually that does need an FM in there. We do need to have that. We actually need to have that in the table setup because of the way this thing is working. The way it did it before was it just kind of threw it into a thing. Here, I'm going to close this because we don't need it anymore. And then I'm going to, this is our original code. This is Hajiwo's code. So what happens with his table set? Mod parameter, push switch, where are we? It does a frequency calculation. We're doing this in handle analog, I think. Or we're not doing it at all right now. That may be what's going on. Well, that's still our main loop. What does Hajiwo do? He just does the wavetable setup. Oh, and he runs table set. Maybe this is something I did. I don't know. Table set is the big one. But if we're running table set, and our mode is not 0 or 2, it doesn't do anything. But it sets up wavetable of I. Oh, table set only does wavetable. That only does wavetable, which is all the way up here. Populates wavetable for modding. Huh. Still subbed here on the dark side. The dark side of what? That's 2 months. Thanks, Wonky Robot. I appreciate that. How you been? It's a good name. It's a good name, Wonky Robot. Yeah, all right. Back to code reading. Sorry, I'm like deep into this. So this technically this should have another if statement in there, and I don't know what it's doing yet. If mod switch is equal to 3, do some stuff. Mod 3 is FM. And just for organization purposes, that should be there. What FM is doing specifically, I do not know yet. We will get there. I keep hitting shift and then scrolling right and left. So I guess we've done the tables haphazardly, which would be octave set, and then it does table set, and then it sets up wavetable. If it's in FM, it doesn't do anything. Yeah. As if I don't have to code these things, I'll just leave comments that I'll have to do something later. Yeah. So, okay, moving on. We then begin serial just for troubleshooting and tuning. And then we unbounce our bounce. So debouncer attach button input pull up, and then debouncer interval of 25 milliseconds. I have a thing here to indicate that we're done setup. I haven't done that yet. Possibly we would do like an LED blink there just for like, hey, how you doing? Or we just have it blink with the mode that it's in, which would be something that the LED handler does. So then we have our loop, and our loop should not be a large amount of code. It really shouldn't. In microcontroller stuff, and especially if you have a program that is as complicated as this, that's responsible for taking in external inputs, scaling them, tuning them correctly, and then doing an output, you would want that, what I just explained, to be your loop. It's just much easier to follow. Debouncer.update, since it's just one singular line of code, what that does is that updates the debouncer code, and it makes sure that, well, it senses whether or not you've pressed a button for a certain amount of time. That will trigger stuff that we've told it to later down the line in the button handler. So we read our analogs, we make the frequency, we handle the switches, and then we handle, so make frequency needs to be further down. That needs to be further down. Because what these other functions are going to do is just read stuff just regularly. Make frequency is what's going to do all the stuff. That's going to make our frequency, and then we're going to output our frequency. So it's read the analogs, read the switches, read the button, make the frequency, and read and respond to the button whether or not something has happened. Oh, apologies, Wonky Robot. You're over there on YouTube. Oh, yeah. So let's take, I forgot to do that. I need to reload the YouTube page. I need to open up my stream. I started with no intro, so I kind of missed some of my steps here. Mute myself, and then pop out the chat. There we go. Okay, now we're fully set up. Now we got YouTube going. Bada bing. Okay. Cool. Go back to the Twitch window so I can monitor Twitch. That's where all the viewers are. Up to 10 people on Twitch. My God. My God. Okay, back over to here. So, read the analogs, right? I don't know why you guys are laughing at my function name. Read the analogs. So when we read the analogs, we store frequency mod, frequency CV, mod knob, and mod CV. We are scaling them from 0 to 1024. They come in as 0 to 1024, but in order to get the maximum of the scale, I am taking what we see on the outputs. So individually looking at what the control voltages do to the inputs to the microcontroller so that we know a -5 to +5 will have the 0 to 1024 effect that it's supposed to. So in this, we are also reversing the inputs. So we put these in backwards. The scales are backwards, and that way, when a 3-volt signal comes in, that will register as a 0 instead of a 1024. Pot scaling is a pain. Yeah, the original code has just a multiplier on it, so I figured this would be a little bit easier for me to tune. In terms of tuning the frequencies to be the right thing, that's going to be a little bit difficult for us to do, and I'm going to have to figure out how to get that 1 volt per CV without pulling all of my hair out. But we're not allowed to do that until we actually get the thing to output stuff, which is why I'm pushing to do it today instead of burn the subs. We should have been working on burn the subs. I promised, and my promises are worth dog shit. I really need to get this VCO out because I just told Dave and Julian about the existence of it. So they need to get their VCOs. They texted me wondering when the next time I could get them in was. So, and if I can get them in here, we could have a grand old time. Yeah, it's 1 volt per octave. Did I say 1 volt per frequency? My brain is in 3 places at once. Anyway, so we get all that stuff in, right? We read the analogs, and then we make the frequency. So what are we doing with that? I guess oscillation frequency is then calculated. So integer knobhead is equal to a map of the frequency knob from 0 to 1024. We take that and we make it 0 to 127. We should do that with a bit shift. That should be a bit shift. That would be much faster. I'm using the Arduino functions. It's a 133 megahertz microcontroller. I could slow this down if I even wanted to. It's a very fast micro. I said 1 volt per CV. That doesn't work. that's regressive. You get into a loop on that. 1 volt per octave is, you know, it's all written out here. 0 to 1024 from 0 to our octave scale, which is like 1230 or something like that. And then we take the frequency and the switch and we calculate that out as per this number here. 122070 does not seem like the right number though. That seems like a Hajiwo number. 122070. One place in this entire document. He does go through some of the other stuff though. So wait, no, but this is he's using the RP2040. So Haji was using the same micro. It's about whether or not where he gets his source code is also available in the link. And here's that's right, the Buchow link. Buchow 125 over 65536, 1907. In this code, the number of quantization bits is 10 bits, so the frequency is 122.07 kilohertz. That's what that number is. Quantization bits is 10 bits, so the frequency is 12070. Digital amplifiers that use PWC use frequencies from 250. 10 bits. In RP2040, okay, so that's still us. Maximum value of the counter can be specified with a range of 16 bits. If you specify 65535, maximum value that can be specified is in 16 bits. PWM output frequency will be 125 or 65575, 1907 hertz. Frequency is too low for audio. In this code, the number of quantization bits is 10. So the frequency is 12207. So that would be, what is that maximum 10 bit? Is that the 1230 number? Max 10-bit number 1024. So it'd be 133 megahertz over 1024. What is that equation anyway? Hold on, let me pull up the calculator. Calc. Bonk. 133 megahertz. That's kilohertz. Megahertz. Over what? 1024? 129,882? 122,070? What am I doing wrong? Pot scaling is all fun and games until someone at the factory mixes up the linear and logarithmic resistive elements. Oh God, I hate those. I hate those. You have to order so many parts. I think Ben Gizmo did this calculation for us, and he did me a disservice by doing that, because that means that I don't understand what's going on. I can be told what's going on only so many times. Maximum value of the duty ratio does not necessarily need to be a power of 2, but in order to play audio with a predetermined quantization bit number, the sampling frequency such as 16 bits, 44.1 kilohertz, sampling rate must be set in any case. You will need to redo the conversion or quantization. Pico Extras has a PWM audio. It's a highly functional library, which includes functions such as sampling rate conversion. That's this. It's not that ARPi2 common, Pico audio, PWM. That's kind of neat. If I wanted to make it a little bit more organized. Find Pico audio, blah blah blah. Audio assert X. Jeez. All right. Well, anyway, that's just confusing me. Maximum value of the counter can be specified within a range of 16 bits, but we're using 10. We have 6, well, the 6 octaves doesn't matter. It's about the number of quantizations of the PWM frequency. 125 megahertz of the PWM output frequency. But this is still using an RP2040. I don't think the Raspberry Pi Xiao does things any differently, does it? What's our PWM frequency here? Well, we're setting up our PWM here, and we're giving it 1024 quantizations. And I guess that has something to do with the clock rate. But he said 125, and we're running at 133. Where does that gets us 122,070? I don't think so. Maybe 256 times oscillation. Well, 256 in our tables. Sorry, chat's getting covered by Windows. I'll come back over and read you guys. Nope, nothing. Nobody said anything. That's why I look at the OBS window often to get chat, just because I have chat in the corner of this monitor. It sits behind the panels right there. But if I'm looking at stuff like this and I'm pulling a window to the side like that, that blocks most of chat. Probably should have it always on top. We're not important. You guys get mad if I don't look at you. So what specifically are we doing, and where is this coming from? This is why we're doing this read through of the code, is so that I can figure out what the heck is going on in this program at any given point in time. So what we'd be doing in the original code is we would have gone through the table set, and then we would get to the frequency calculation. When we do the frequency calculation, because that's in the loop, we get the push switch, or we store the push switch so that it can be pressed again. That's the same thing as our debouncer update, only ours is better. But octave select, we look at the switch and where the octave is selected. We then look at the mode. We figure out what mode we're in based on the switch. So FM, AM, or wave folder. Now I have a function that'll do this now. So and our mode numbers are different because of the way that I'm storing them. I'm actually storing them a little bit differently. The mode isn't selected when we go through the initial table set, is it? But we make that frequency table. I guess we have a table set up. How does that work? Well, anyway, okay. So this is where we figure out what frequency we're in based on the analog reads. So once we punch those analog reads in, we then have frequency table value of ADC plus the frequency pot, and then we calculate the PWN frequency. So this would be 2v6 times oscillator frequency over 122070 times 1 plus octave switch. I think that's calculating our... No, but none of this uses the mod or anything like that. We're just making... What? We're making a singular value of oscillation frequency. I guess oscillation frequency that represents the energy level that we're at the moment. But we're using wait. Oh, we didn't actually get the value here. We need to get the value. Whoopsie doodle. Keep scrolling to the side. Where did I just take us? What is going on? Okay, so here we actually need that other line. We need this one. Frequency table value of the ADC read plus the frequency potentiometer. What are we calling that? We're calling it's not ADC. It's mod CV. It's freak CV. Freak CV and freak knob. Oh no, we're doing these. V scaled and knobbed. Okay, there. So knobbed and V scale is going to set, based on the frequency table that we made before, it's going to set OSC frequency. OSC frequency is a function of 256 times OSC frequency over 1222070 times 1 plus the position of the octave switch, which sets it to 0 octave, 1 octave, or 2. 0, 1, or 3, which I guess becomes 1, 2, and 4. So 1 octave, 2 octaves, 4 octaves. 1 plus is over here for some godforsaken reason. But that has the OSC frequency. The frequency table value of that then becomes, so what happens to OSC frequency? Because that needs to be applied to the mods and stuff like that. So this is strange. So we end up with OSC frequency at some value. The derivation of this number I'm still curious about. I'm still curious about where that number's coming from, and I don't think we need to change it. Although I think we've already been recommended to change it by somebody who for some reason thought we were on a different microcontroller. So 122070, explain yourselves. Hajiwo does not mention the number anywhere. He might in his other write-up. So this would be an update, right? Or is this the original? Let's go all the way back up to the top. Yeah, this is my 53rd self-made modular synth. When I conducted a survey on my YouTube channel, the Raspberry Pi Pico VCO was the most popular. However, Raspberry Pi Pico only has a 3-pin A to D converter, which is a bit inconvenient to use as a VCO. It was a problem. Meanwhile, Seed Studio released a small microcontroller board called the Seed Zhao, I don't know how to say that. The Zhao RP2040, since the AD converter has 4 pins, I thought this would be possible to create a VCO with the minimum configuration, so I planned this module. So the code of the original Pico VCO is what I think we need to look up. So let's search Hajiwo's channel. Search Pico VCO. That's the RP2040, 2040, not a Pico. Why is search so bad? Zhao VCO. Look at that one. That's DIY modular synth. Overflow folding. Oh, that's probably where he explains that. Man, if I kept up with the Hajiwo stuff, I'd probably know what's going on. Chord VCO. Second year. Circuit module. Damn, I can't find anything. Okay, hold on. Let's look at the list of videos then. This is all really cool stuff. Okay, so where are we getting our Pico? There's our RP2040. I'm just looking at the pictures at this point. $1 LED cables, sign me up. Solenoid? No. S&H, distortion, wave shaper, envelope follower, piano. Come on, where's the Pico? Actually, Control F Pico. Where is it on the page? I hate this search sometimes. It says there's one. Where is it highlighted? I feel dumb. Why can't I see it? YouTube search is powered by Google. Oh, well, that explains that. Where the hell is Pico on this page? What happened? It used to be cool. All right, I guess I'm back to just searching by picture, because it also hasn't loaded ahead. I can't believe we wouldn't be able to find anything, because he's directly referencing his old one. He just doesn't have a link to it. I mean, I could just look up VCO. Maybe that's what I should be looking at. VCO. $25 Eurorack with hard soft synth VCO arduino uno R4. R4. CJAO. Where? Show me the Pico Pi. It might be in the wave folder. Might be one. I want to see what his old code is and his old explanation is, because I have a feeling, I figure that the explanation of where these numbers are coming from is going to be in that, and that will allow me to further my code. Ugh. These little trip ups are what always gets us during stream. I would have a wonderful and exciting stream if I had any idea of what the hell I was doing ahead of time. If I had even the slightest inkling of what the heck was going on at any given state of time, I would rule this platform. Why is this impossible to find? Does he link to it in his? He might link to it in his article. That might be what one of these is. One of these is. RP2040 and Arduino, SeedWiki, Baptism of a Zhao. Nah, none of that's what I'm looking for. Where's your old one? I can't read this language. Okay, so let's go back to looking at YouTube and figuring out whether or not we can actually find it. Because, is it not in his title? Oh, we're at the bottom. He said he made one with a Pico Pi. Maybe he made it all one word. Maybe it's Pico Pi. Pico Pi. Picopi. Nope. Put the dreaded quotes on it. It almost did nothing. Chord VCO with CJAO. Modular Synth, CJAO. Modular Synth. The Sparkle Cable? It's a bunch of... Oh, it's a playlist, I see. Raspberry Pi VCO, but that's Seed Studio. Looking for the non-one. Digital circuit module? No. Oscilloscope? No. Huh. There's a translate plugin for the Stream Deck? I mean, you know, this does fine translating. That page actually was translated by Chrome. It was Google Translate doing it. Yamaha PCM. Summary. Ambient Jam prototype. VCO Volume 1 overflow folding. Did he say what number his original one was? Maybe that's how we find it. This one is the 53rd. Oh, maybe he didn't actually build one. Like, are these things that he hasn't built before? So this is a new thing. I think that's what it is. He's never built one with the Pico. He realized that he couldn't do that, and so he did the RP2040 instead. So that makes a little bit more sense, but it doesn't get us closer to where he originally derived his numbers from. We have this article, but this article doesn't necessarily give us exactly what we're looking for. Like 125. Okay, so these cannot be determined independently. The product of number duty ratio stages and sampling frequency becomes Pico's PWM clock. The standard clock is 125, so if the number of quantization bits is 10, equals 1024. Okay, so we're 125 billion over 1024, so this number has to change. So what I need to do, and although there's probably a programming structure that I can access that would have the number in it, what I'll do, this is our framework, okay, we're in the right one. So we already have OSC frequency there, right? OSC frequency, well that's, no, OSC frequency is the number that we already have. This number, where the hell are we? I'm just gonna like have a fugue state. I'm just gonna completely lose my mind. 122070, that's gonna be our like calc thing. What's that gonna be? That's our quantization bits. So qubits, and our qubits, we can just calculate it here. Define qubits, and that's going to be, that shouldn't be, those shouldn't be spaces. That was dumb. There's one space. So it's OSC freak over 1024. 1024 is these are weird numbers. F035, scale the input. So it's the, but that's not it. That's the, yeah, so sampling rate. Sampling rate. That feels like the PWM CDIV. Sys clock. I guess I'll just call that sys clock. Over resolution +1 times frequency is slices. I'll leave the question mark in there. So okay, so what do we have? We have 133 megahertz. So this number does have to change. 133 kilohertz megahertz over 1024. 129882. Weird. I guess it can't be a decimal, huh? The other one was 120. It's, well, they said 125 megahertz and they got 122.070. They got a nice number. We got 129.882. We got a weird number. Oh, that's kind of cool. It translates to anything you highlight. All right, so to the best of my knowledge, we've got the right number there for qubits. So now we take that number, which is a time-dependent number. That's the how quickly we are going through the stuff, and we divide it by 256. Why? Oh no, that's not that's different. That's a different equation. Where the hell? Where are we? What is this? What is this place? Where have you taken me? There's just a whole bunch of weirdness going on in this program that I'm trying to get to the bottom of. So we're figuring out what frequency we're currently oscillating at, what frequency number it is, and that's based on the two knobs. So this is basically the request. So I request this frequency. So this frequency is a function of the knobs based on a frequency table that's set from 0 to 6 octaves, right? 0 to 6 octaves. And so we're figuring out where in that whole scheme of things we are. And then we do weird stuff based on the timing of our PWM output. And so this is the beginning of turning it into that weird frequency thing. So we take 256 multiplied by whatever frequency we're requesting, we divide it by qubits times the octave. So the number of bits in, the number of what? The time slices times the octave? That's it's a strange thing. I don't know what that's doing. So yeah, we look up a value of the table and then we turn it into something that's, I guess, useful to us. All right, so we've done that. Jeez. Once we've done that, what do we do? The mod parameter set. So that would be reading the modifier. So actually, before we make the frequency, we get the analogs, we get the switches, we get the buttons. Then we set the wavetable. And we make the frequency. Are we still called, it's still called table underscore set. I'm going to turn it into table set like that, just so it's our camel cases and our underscores are, it looks like I'm mixing them no matter what. Okay, whatever. I'll just call it table set like that. Looks better in my other. Table set up. And I got to come all the way down here. And I got to do table set and table set up. Well, I'm using underscores here. Oh boy. Table. This is why you should do things right from the beginning. Table setup. This is basically the octave select, but then table set. I don't know if I have table set's that little one. Table set. Okay, so we've done that, and then we come in here and we get the mod. I mean, it looks like Hajiwo has the basis for organizing things the way I want them to be organized. He's got these headers, and instead of the headers, he should turn those into functions. I know, that's a great use of Control F, but I'm doing things my way. So we get our mod, like what the analog value and the CV value combine into in order to give us mod. And there's some weird stuff that it's doing here. 0.0036 plus 0.9. Constrain the analog read of pin 29, analog read of 28 and 29. So we have the control voltage and the potentiometer. And they're constrained from 0 to 1023, but they're just added together. So that seems like a weird way to scale things. Let's see. I mean, it's what it's, but the only reason I know that song is because I think a Burger King commercial. Oh yeah, it's too easy to miss stuff when you do it that way. Too easy. So we've already read our analogs. I mean, I guess we're doing the business of making the mod. And depending on what mode we're in, the mod value changes. So we'd have to do mod, I think is our next program here, our next thing. We table set, but actually the analog reads, should we make that a separate thing? Because once I get those values in, I'm putting them into variables and nothing else is done in them here. We just load up our big variables with it. So we should do that as its own thing. So we do the button handler, which sets our waveform mode, and then we do. So we read the analogs, and then I guess right after I'm going to make. Well, wait, where did I do that? I did that wherever I make it. So I've already read the things. So wherever we're using mod, but then that is dependent on mode. I guess when we table set, I should also incorporate mod in there, because that way we've got everything to happen here. So if the mod switch is equal to 3, 2, or 1, Maybe I should make that a switch case. Yeah, we could do that. Switch, but then I have multiple things going on in here. So mode switch, but then mod is a different value, and I guess we need to make that. So our mod all the way up here, what is that in Hajiwo's code? Float. It is a float. Float mod is equal to 0, and then down here we have our table set, and when we set the table, we also set, so populates wavetable for modding, also populates mod variable. Because that's mode dependent. We can just keep all the mode dependent stuff in one area. So the question is, so for wave folding, that's what mod is equal to. I mean, I guess I could grab this whole thing and I could just replace that with our variables, but it seems a little odd to me. Yeah, maybe we'll just do a switch case. That'll look a little better. Case of 0, well, case of, yeah, we'll do them in order. Case of 0, and that one is, oh, 0 does nothing. Okay, case 1 is AM, and what that's going to do is it's going to run AM, but it'll also do whatever AM does, and AM takes, am I populating one variable or two? I think I'm taking two. Yeah, we're doing two. So mod knob and mod CV, 0 to 1023. Mod is equal to constrain mod knob plus mod, no, CV. Mod knob, mod CV, right? Yeah, mod knob, mod CV. Capital M? No, 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 no. No, 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 no. Those will all come out in the wash when we actually try to compile, but... Which one is our REM statements? Which is that? I want to get this done. I really want to get this done because I'm sick of coding. I know you guys are too, given all of the viewer that I have. There's a couple of you that are dedicated, and it's really nice to see, but yeah. So we do the mod, then we do the AM thing, and then we break. So AM does the business of making, let's just find AM. FM modu, which FM modu makes, where's my function? So that would be down here, and that populates wavetable, as does the, well, that makes mod 2. This one makes regular wavetable. Weird. So the original, this one makes regular wavetable for AM. For other ones, it makes the other, okay, so populates regular wavetable. Mod is equal to constrain mod nom mod CV 0 to 1024. And then we've got this wonky numbery thing going on here. No idea. I have no idea. I don't mind the coding stream. I'm trying to learn through osmosis. I like to have a little bit more fun stuff going on, but this is like pure coding. No more Fartbox. I'm getting into Node-RED. I'm starting to get into Node-RED. I've only just started. I need to set up a timer for the light for my hot peppers that I'm going to be growing. I need to plant those. That seed starter thing is at the bottom of there. With the seeds that were in the refrigerator, and I've taken out of the refrigerator. So I think next year I'm going to have to buy all new seeds. But anyway, I'm going to plant that whole thing and get that going. That's probably what we should have done today, is like, fuck coding, let's plant seeds in the ground or in this plastic thing. Because I've set up the Tasmota switches, and I've got Node-RED, and I've looked into Node-RED again, and I'm starting to remind myself about how Node-RED works. And I got a nighttime timer to turn on and off the switch for the lights for those things. I'm going to set that up soon. They're going to sit in like a corner of the shop or something like that, or maybe, you know, just outside where I can monitor them. But not Home Assistant. No, I'm using Node-RED. It's just straight up Node-RED. And I want to get the Twitch events in Node-RED because I've got OBS in Node-RED. I want to get the Twitch events in Node-RED because I can do things like, you know, when I go to this camera, the light turns on. And when I go to this camera, it turns off so that the cameras aren't all weird, right? That's a really good thing that it does. So I want to get Node-RED then to take all of the Twitch events and coordinate things. And that means reprogramming the Fartbox to respond to, I guess, HTTP requests. That's probably the way to do it. That means it'll need to get its own IP and everything. Anyway, AM makes wavetable. So then if we do case 2, I'm getting it's all backwards. Case 2, we're doing the business of wave folding. It's just the positions of the switches correlating to the numbers is not as hard set as you'd think. So mod is now equal to 0 to 1024 over 8. Actually, let's do this. Let's make it even simpler. Wait. Yeah, 0 to 1023. So int, actually, well, mod is equal to the constraint of the knob and the CV. That way, for the next case, we don't have to do anything. So all I need to do is mod is equal to mod times mod over 8, rather. Mod times over 8. Case 3. There. Take out the commonalities. Give that room to breathe. And this should be, I guess, 1023. I guess. WebSocket, yeah, I mean, that's what the Tasmota devices are using already. They're using WebSockets, and they come in with a friendly name. So if I had a friendly name that was just Fartbox, that would be much easier to Node-RED with. You are correct. If you want to go down the rabbit hole, you can use Home Assistant. You can use Node-RED with it. Node-RED's all you need. ESP Home, MQTT, and other cool tools. Yeah, there's all kinds of cool stuff like that to like actually make your house into a smart house. And this is where we should do the business of FM stuff, huh? Yeah, that one's just, oh, it's 1023 minus. So actually, mod is equal to 1023 minus mod. If that's going to be running multiple times, no, this is going to be overwriting it. So yeah, that's fine. This will overwrite the variable, and then when we go down and do the business of the case switch, we're going to write it again. So that'll always set it correctly. And then we need, over here in Yeah, we have wavefold in there. And then we don't need this. AM wavefold, and then what does FM do? What FM do? Well, it doesn't do anything on table set. So we're coming down here and we're looking at the push switch digital read of pin 6. That's whatever. We've updated this. And if it is in that specific mode, then it will run table set. So if the push switch, one sec, let me think about this. Waveform plus plus, waveform's greater than 7. If mode is equal to 0 or 2, it's going to table set. So 0 or 2, it's going to table set after it's done. It's gotten the mods, it's done this thing, it needs to go into table set. If it's in mode 0 or 2, it'll run that program. And I guess what I'd like to do, maybe I need to take table set and make, that's what I've done. Every time the waveform changes, we run table set. And so in FM, because that's where table set here, we're looking at the, oh, but table set, hold on. I'm starting to, okay. If we're running table set every time, or we're not setting the frequency differently, if our mod value changes, that's not going to set things any differently. So we can't roll these together because the mod value is going to change constantly. That will dictate what we do to the waveform later when we output it. When we output mod wavetable 2. Because somewhere along the line, we're taking our wavetable and we're adding a wavetable 2. If mode is equal to 0, if mode is equal to 1, if mode is equal to 2. See, this makes mod 2 wavetable based on a scaling of the mod number. If mode is equal to 2, what if mode is equal to FM? Then we make it directly and we don't use any of the other wavetables. If it's AM, we use that wavetable that we calculated. If it's wavefold, we use mod wavetable. Mod wavetable is derived from wavetable. FM's the only one that doesn't use wavetable. Whew. Yeah, we got to make sure that all the right stuff is happening so that we can get all of these numbers. No red is a lot of fun when you get down to it. Much easier than what we're doing right now. This is table set, and if table set uses mod, but mod needs its own thing. Mod calc. Mod switch, and then case 1 break. We got to do it this way, I guess. AM, wavefold, and FM, and then we take on mod calc, we use mod, and we constrain it. And then we do, this is not needed here. And then we take this. That one's AM, yeah, okay. Gotta get the comments out of there. Take this. And we take this. This is all just in the interest of organizing this code. Damn it. Okay. So now in here, we only have the one thing. So mod calc has to happen somewhere after reading the analogs. It doesn't need to be in a particularly specific place. So now when we table set when we hit the waveform button. So that should happen every time we hit the waveform button, we table set. If mode is equal to 0, wavetable size is equal to wavetable mod. I is 256, 0 to 256, then this multiplied by, if mod is equal to 0, then we're making our mod2 wavetables with this function. This one is our just part of our main loop. But this one, I have mod2 wavetable of all of the FM modes. And then the AM mode, I'm so lost. Wavefold and FM I've already made into big functions. That's the, yeah, wavefold and AM. And then I guess I just need to make an FM. But wait, AM is the one that's not populated. If timer plus timer less than or equal to micros, k plus plus, if k is greater than 60, k is equal to 0. AM mod sine of m2 pi, so here's this thing again. Make modulation sine wave for I is equal to 0 to blah, blah, blah. Mod wavetable, AM mod. Multiply AM sine wave. Timer is then equal to micros again. What the heck? But if mode is equal to 2, I think maybe there's an error. Mode is equal to 0, and mode is equal to 2. For the different waveform types. Yeah, modulation and modes. It's very confusing. Exactly, that's what's going on in my head, and it's very confusing to me. I'm trying to figure out, like, it's how this thing is making the various waves. And I know it's doing, like, it has a specific waveform to follow, and then it has a modulation for that waveform to follow. Because the modulator is what creates that audio. And I'm just getting a little bit lost. We've made our mod, like our mod value, the modifier value. So wavetable 2 is the one that's output. And if we are in mode 2, which is AM modulation, this may be a typo. No, mode 2, AM modulation. Mod 2 wavetable of I is equal to wavetable of I times AM mod, which is sine of 2m pi blah 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 16. But then if mode is equal to, that's mode. Yeah, mode is equal to 2, and mode comes down here. If mode's equal to 2, then we have a specific AM waveform that we follow. In order to make the wavetable, could I roll this into the other one? I think I can. Because I've got the FM wavetables. These things have their own function to make mod 2. And then this one makes mod 2 out of the mod wavetable depending on the waveform. Okay, I think I'm getting it now. I'm starting to get it. So what we could do is we could do 2 different functions. So AM and then AM mod. And this can run FM. Well, it doesn't need the mod, I guess. It doesn't need that because FM does it in one step. FM does it in one step. So that would be, FM would just be, well, that one says AM. I don't think that's correct, is it? Sine 2 pi mod blah 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 mod over 128 mod over 128 mode is equal to 1. That's FM. So it's actually not AM. This is FM. That one's FM. This one is wave folding. We'll keep it as wave fold. So we just run FM, and that makes mod wavetable 2. Wavefold just makes mod wavetable 2. No, wavefold is actually a different thing. Wave folding has its own way of functioning. So wavefold needs to be a different one, and this one is just AM. So this one is AM. And then we need... Oh, wait a minute. Hold on. Yeah. That one, that one. FM modulation of the things. FM modulation of all the things. Wait, I think that one's actually... I think modulator is actually FM, if I'm correct. I have nothing to lose. Yeah, so this one's actually FM. What's the difference between these two? Oh, this one is just a copy? Hold on a second, now I'm confused. Depending on waveform, FM modu creates... Yeah, this one creates wavetable, the other one creates mod 2 wavetable, creates the whole thing. So that's what that one is doing. So this is the one that's correct. But then these two, what do they do? If the mode is equal to FM or AM, and if the mode is equal to wavefold. So that is actually AM, and this one's wavefold. But then after we do all of that, we need to then do the business of the wavefolding or the business of the AM. So I need to write this down here on AM. So first we do wavetable, and then we do the wave mod 2. I don't know where we're making wavetable, like mod wavetable for output. Those functions make wavetable 2. Really, to be honest, the making of mod 2 wavetable should probably be in its own function, but whatever. We're coming through here. We're making our FM modulation table, and then we're making our mod 2 wavetable. Are we doing this every single loop? That seems a little odd. Yeah, maybe it should be a wave pool, and we should all put our little floaties on. Like if the waveform changes, otherwise just do the modding. I think everybody would pee in the pool, and then the person who's not peeing in the pool would get the blame. So previous waveform. Oh my god, this is ridiculous. So int waveform, but then also int prev waveform. -1, or make it equal a number that's not possible to get to, because when we read the EEPROM, in order to make our waveform number, then it'll change and all the calculation will get done. Call me crazy, but I don't want a guy named Poopsie Doodle in the pool. Why, you don't like floaties? This is getting complicated and I have no idea what's going on and I'm starting to get really confused. Okay, so we initially come through, read the analogs, read the switches, read the buttons, or we figure out whether or not the button state has changed. Can I read if the debouncer fell multiple times, or is that not going to be valid? If I read the debouncer and it says debouncer.fell, I wonder if I can do a bunch of stuff and then set the debouncer back. Because really, all of this calculation stuff only needs to happen if the waveform changes. So like if, where are we doing that? Where's my switch, my button handler? Table setup, PWM setup, test prints, we're all the way at the bottom. Scrolling up. Well, before I lose sight of what I was doing, that's that, and then this is wave folding. Let me just put this in there, and I'll have to rewrite it to be a little bit more clear. See, I'm wondering if I could do if debouncer fell, and I could do that. That way it's like we know something has changed, and I don't have to do the variable shuffling. Button handler, read analog. Okay, so read analog, make frequency, switch handler. Those are the switches, so those are much easier to do. Button handler, if debouncer fell, waveform plus plus. If waveform, well, okay, yeah, I guess. Previous waveform is equal to waveform. So then it increments over so that I can check to see whether or not they are equal or not. And then when we are done the business of the whole program, we set previous waveform is equal to waveform. So that we do all the stuff and then we set it to be the same waveform and then we come back through and we know that we don't have to make those tables again. So now on all these messy BS pieces, I can do, oh, I gotta indent it again. Bop, bop. If waveform doesn't equal previous waveform, do all this stuff. And then I do that to this too. If waveform does not equal, see, it would be better to do like if debouncer.fell. Well, we're not updating the debouncer, so actually I can do that. Hold on, where's my debouncer? I can do that because we're not updating the debouncer, and that way we don't need all of that just to get rid of this line, right? So I look at, because this is when it would reset whether or not the debouncer has fallen. So if debouncer fell, we don't need this. And then I just take this if and I put it everywhere else. So if debouncer fell, then stuff changed. And we do that. And then we do this anyway because the mod value can change moment to moment. Although we are doing a lot of calculation. Where's mod wavetable created? I gotta look at that. I have to figure out where that one is. So if debouncer fell, do this stuff. That way we're not making all of this stuff over and over again. For FM, we are making it every single time, though, because that makes mod 2 wavetable based on mod. So every single loop, we have to change this. That's a little weird, isn't it? I guess the interrupts are really where all the work is happening. Yeah, it fell and it hurt itself. Just because it has this mod value in it. I mean, I guess I could do if, like, store a previous mod and store the current mod, and then if stuff changed, then it'll change stuff. I don't know. I guess it's all right that this thing is writing itself 10,000 times per cycle. You know, if you have everything sitting exactly still. Oh, that was a sub message. Chester Willard, thank you for the 44 months. Sorry about missing, like, kind of partially missing that. I did not mean that. I'm going to get follows out of this thing. Hold on. Wait, I thought I already filtered it. Huh, weird. No, I guess I keep follows on there just in case something big happens. That's why I have the other one open. Let's let that load. There we go, yeah. A couple things happened. 2 days ago, Groovy subbed. I think I thanked him for that, but I got Celia Russell for 77 months. I got Wonky Robot for 2 months, which is awesome. And then Chester Willard was with the mod wavetable, mod table, mod wave for 44 months. Ask GPT to finish it for you. Ask GPT to fucking explain what the hell is going on in this code to me, because boy howdy, I am confused. We're getting there, though. We are getting there. I'm just wondering where mod underscore wavetable comes from. Because that's what FM uses, doesn't it? No. FM does not use any of the wavetables. It uses this absolutely cursed absolutely cursed sine wave function, the polynomial sine wave function. This one is FM modu, which is used by AM, which is a little, well, it's waveform. So I guess instead of FM modu, I'm going to call it WF. WF modu. Because WF doesn't use mod, because then the mod is then used to fold. Well, it's more like C++, really, to be honest. This is Arduino. It's RP2040, but it's Arduino code. And we've got basically an infernal set of equations. This is coded by Hajiwo, who creates cheap Eurorack modules. We're trying to make a VCO, and this is like the 10th stream that I've done on this VCO. This is another one where we're just looking at code all day. I've got a lot of stuff juggling in my head right now. I'm trying to figure out how this thing creates the waveforms, and so far what it's doing is it's populating tables and then calculating things based on the population of the tables. This one, however, is wrapping stuff around. This wraps stuff around as you increase the value of mod. And as mod comes in, it gets scaled differently. It seems as though I should be doing this all in like each program. Like we should take those, we should scale the values here. Like when we do AM modulation, we should scale the values. Maybe that's how I should do that. That way, we don't have to do the business of reading the mode in multiple places. The switch mode squad. So what would that look like? I mean, basically what I would do is I would take these cases out, and I could just take them into each individual. Yeah, so let's just take this out. Oh, but it has to have constraint on it. Like, this is a pretty clean way to do it, but I guess we could just throw this into, or I could run mod calc, but that would still do the switch mod switch. So I mean, we can read it in multiple places, that's fine. I just think it would be better if I did, like when we go in to do the AM modulation, I have all of my information in here. So if I go in to do wavefold is this one, so it's mod equals mod over 8. I mean, this does display more clearly that it's doing something different for each one, but I guess if I do wavefold, hold on, let me just grab this, grab the whole function. and delete the references to it. Oh yeah, and this actually needs to be activated. Get rid of mod calc. So now when table set runs, it'll go to AM, wavefold, or FM, depending on how the mod switch is set. So AM, wavefold, or FM. So we come down here and we reach wavefold, and wavefold gets us all the way to mod 2 wavefold. So we take wavefold from here and we make mod out of it. So mod is equal to constraint of the mod knob and the mod CV that we got from a previous function, and that'll create that right there. Oh, get rid of this. So while it's one extra line, you know, whatever. And then this one calculates waveform. And then calc mod 2 wavetable. If the bouncer fell, and then we're gonna calc mod, and this is for AM. I don't know if I like this. There's nothing specifically wrong with it. It's just that, I don't know, the common stuff that could be happening here. It just seems kind of odd to me. So we calc mod, and then we if the bouncer fell, switch, and then all these cases. So this is calc wavetable. And then we mod 2 wavetable for output. And then for FM, we calc mod. Which is 1023 minus constrain. I like having a lot of little functions to do the thing, but I think this might be a little bit better. There's a switch for the waveform. Forgot to indent those. And then this is, well, no, we can't do an if, can we? This one takes the waveform and applies it per case. But this one makes, so calc mod 2 waveform, since mod changes, no if, or mod is used. Mod is used in the equations, there's no if. The only way I could do that is if I store the previous mod value and then compare it. I wish my brain had a little function, yeah. Sirens, blah. The best you've done is make sirens at university on a PC speaker. Yeah, this is, what this is doing is it's using a Sallen key filter. I guess it's a pretty common thing, but the Sallen key filter operates the output voltage as if it's some kind of a Flappy Bird game. So if you're hitting that with a PWM that you keep interrupting, not interrupting, you let the PWM expire, but you're giving it a different amount of high voltage value during its, like, for however long of a slice you're doing that PWM for. So you got your PWM and it's got a fundamental wave, like
available length, and it changes the amount of that PWM based on what you set it to. And if you have it go through a sequence, it can basically tap values of voltage onto your Sallen key filter. Sallen key filter smooths that out and makes it into your wibbling wave. So you have a very high frequency PWM that's hitting it with levels of energy, basically, and those levels of energy are influencing where your logo, your cursor is, essentially. Logo, there's a deep cut. That was like the Apple II logo writer or whatever. So what I'm doing is I'm like, we're making these big tables every single time the software runs. Like every loop, we're making these huge tables. And while we are 133 megahertz, which is an insanely fast processor, I feel bad about making these tables every single time we run. But in some cases, we can't really help it because the FM modulator relies on the mod value in order to calculate what that mod 2 wavetable is going to be. Which really, I mean, like anything that would stick should stick, but that appears to not be the way it runs. So we come through here and we calculate the mod, and then we run the FM wavetable, and then that goes into whatever value of slice is slicing it up. I guess the interrupt and the slicer are operating much faster than this, so it's just weird though. So that's actually, this should be here. If timer plus mod is less than or equal to micros, K++, if K is greater than 63, K is equal to 0. Let's bump that over to one line. And let's clean this up a little bit. And then AM mod is equal to, and AM mod is probably a float, right? That doesn't need to exist outside of this function. Wait, yes it does. Okay, yes it does. No, because where else am I using AM mod? Yeah, I'm just going to leave it in, it'll make space for this variable every single time. Float. AM mod is equal to sine 2 pi m blah, 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 over 63. For 0 to 255, I mean, why am I not just putting that down here? Because we're not going to run another K. So if K is greater than 63, so if timer plus mod is less than or equal to micros, add 1 to K. If K is greater than 63, set it to 0. Timer plus mod, huh? Strange. Why 63? 2 m pi K over 63. And then for 0 to 255, mod 2 wavetable, and then set the timer again. That's all within, well, that should not be within debounce or fell, I can tell you that much. Where this one's coming from, I do not know. Jeez, okay, hold on. Everybody come back here. You go one indent in, and then all of you go another indent in. There we go. So if we run the timer thing, because timer on mod is less than or equal to micros, we come down here and we repopulate timer. Timer is a long. We're going to use timer for the LED as well. No, we're not. No, we're not. I can't use it for two things. Long AM timer is equal to 0. There's a lot of stuff going on in this, and I probably should have gotten to it piecemeal. Let's see. Table set, AM, FM wavefold, and then these individual functions. And then we have in the AM, we have all the way down here. AM timer is equal to micros, AM timer plus mod. So if K is greater than 63, K is equal to 0, plus float am mod is equal to sine blah 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 blah, and then the mod2 wavetable, we're taking wavetable of I, which I don't know what made wavetable of I guess this did. So this makes wavetable of I if the waveform changes, and then it uses k, which increments every single time. So I guess that's all very necessary, and I can't simplify it any more than it already is. Okay, so am timer is equal to micro. Okay, so that one's approved. Oh my god, the wave folding. So yeah, we're taking positive and negative values, and we're making sure that this thing rolls through a couple different things every time. It's got one function per, so let's just like reduce it down so that it's not as intimidating a block of code. Yeah, it's a very strange scheme. I can turn this on and actually give you a look at how it actually performs. Because it's complicated, and these tables getting set and reset, I don't know if this would be my overall logic if I were to come up with something like this. I really need to make that module testing module. I'm just afraid it just won't have the same precision as all the other equipment that I have here. So here we're running just one of the modulation schemes. There are multiples. I just did this to test our hardware. But if I show you the output of the scope, which is here, what we can see is that we have different lengths of PWM, and as those different lengths of PWM come in, now this is after amplification, but what they're doing is they are bumping up that voltage level. You can see that the voltage level starts to go down almost as soon as that cuts off, but then the next one comes in and it bumps it back up again. So if you keep an over, under, or average, you can affect the actual waveform. And the waveform frequency here is 600 kilohertz. No, 600 hertz. So what is 600 hertz? What is that? 600 hertz, note. It's an image that's a table of frequency values. It doesn't really help. Octave 5F. Well, we can listen to it. Oh no, I've opened it in too many windows. Wait a minute, what's going on here? Let's go back to there, minimize that. Let's go back to here, go back. Here's a 600 hertz tone. That's 600 hertz. So that's what's playing right now. So the math that's going on here is doing that business. This is actually going to be very difficult to organize with all these conditionals here. So maybe I need to just leave it alone instead of doing my fancy schmancy one-line stuff. It's looking for a range of values, which is not really what a switch case could do for us. Oh yeah, the screen capture on the scope. This is a new Rigol. When Rigol came out with their new series, I started lusting after it. And then I had a huge milestone birthday, so I justified myself the cost of a scope that's worthy of being streamed. And so I got the dark mode DHO 914. I wanted to get the base model, but it was white, and I was sick of having a white scope. So now I have a dark mode scope. And due to Rigol being in the 21st century, this runs on sort of an Android base. So I've got USB-C from a $75 laptop charger that Amazon sent me for free, and I've got an Ethernet cable going into the back of it. This thing can probably connect wirelessly. I just didn't explore that. So I plugged it into Ethernet, and I plugged it into my USB-C charger, and now this thing runs brilliantly. The only thing about the Rigol scopes Oh yeah, and they're super thin now. The only thing about the Rigol scopes that I've complained about is the reflective back glass. Not a huge issue, but you get that kind of like, not Black Mirror, but you get the, hold on, Nintendo 3DS screen comic. Where's that one? Yeah, there we go. You kind of get this effect when you're using your oscilloscope, right? You kind of just like look back at it and you're like, oh. But one of the things about using the scope is that when you plug it into Ethernet, there is an intranet site that you can just pull up. You can just type in the URL into your web browser, and you can actually click on those elements and affect the scope. So if you put the scope remotely, or if your employee is using it, you can drop in on them and see everything that's being done and press buttons relentlessly on it in order to make them think that the devil has haunted their oscilloscope. But it's really useful for us because I've got a nice quick display up here on screen so you guys can follow along what I'm doing with the buttons that I'm pressing, and I don't have to worry about keeping this thing necessarily in view. Although it is fun for you guys to be able to see when I'm hitting buttons on it, but I haven't even touched any of the other features on the scope, and there are tons. There are tons. So yeah, this is just our test program. I just threw some of the FM modulation in there in order to give us anything that looked like a wave. But yeah, the new scope I am absolutely thoroughly impressed with. Oh, I've already put an anti-glare cover on it. It was tough. The screen, being that this is tablet technology now, this is just the screen is just glued. It's just pasted onto a plastic backing. So if you take the whole scope apart, you can't get behind the screen. And I was relying on that in order to help me cut out the screen protector, but you can't do that. All right, anyway. There's not much that I'm really going to change here because it looks like all it's doing, the wave folding is doing, is as that mod value pushes you out, right? Because wavetable is just mod times wavetable. As it pushes the waveform out of bounds, it just reflects them back numerically. So that's all it's doing, and it's doing it with if. And it does it 256 rounds of that. There may be a more eloquent way to do that mathematically than looking at values and reversing them, but I guess if this works, it works. So we'll just leave it alone. So basically what we're doing with our make table, or our table set, is we are just making mod 2 wavetable. Wait, how did I do the other case switches? Did I do those incorrectly by putting stuff around them? I got this switch case organization method from some other thing, and it made stuff look... Oh, so not... Yeah, I'm just doing them in line. Okay. Case 1, AM, break. What? Insert? Not you again. Let's turn this into WF. The delete key is so close to insert on this little keyboard that I use. Look at how much cleaner that looks. Beautiful. So table set is just going to check to see if the mod changed, but then it's also going to set the entire table depending on what that mod value. I mean, maybe we should look to see if the knobs change and then it'll make a new table. Otherwise, everything just sits. If the debouncer fell, then we run table set. Table set still checks to see if the debouncer fell. Then we don't need to do that. Or I get table set out of the main loop. So that every time... No, but we can't do it that way because then the CV values wouldn't do anything. Madav Takar, how you doing? I don't know if I pronounced that correctly. I'm sorry if I didn't. I probably didn't because I don't speak languages. I program languages. I don't know what I'm doing. If waveform is greater than the number of modes, waveform is equal to 0. EEPROM put the waveform number so we can recall it again when we boot up. Waveform plus plus. That's all this. That's all the button handler is doing. It's incrementing things. You are an Indian bro. Awesome. We're doing really complicated calculation stuff right now. This program is a total mess. It is originally from Hajiwo, who is a YouTuber who creates very cheap modular synthesizer stuff. And they're brilliant. I mean, he's using, you know, RP2040 and all that other kind of stuff in order to create these, you know, like modular synthesizers are super expensive. So it's really refreshing to have somebody who makes them on the cheap, like $10 US dollar, $5 US dollar modules that he then DIYs, he puts together, and he has this whole modular synthesizer setup. I have been building one as well. And the reason that I have been building one is because my friend Julian finally told me, after needling me for 20 years about building a synthesizer, he finally said, you know, they just sell the circuit boards for these modules, and there's no information on them at all whatsoever. And I went, that sounds awesome. So I built a bunch of these modules. It's been what we've been working on for the past couple, it's probably 8 months, 9 months. We've been working on these off and on, along with Burn the Subs, which is over there, which we will work on again. And yeah, I've been having a great time with it. I've been learning a lot. Mostly the analog stuff has not been working out so well for me. The digital stuff has been going great because digital's easy. So we're building up this circuit board that I built, which is a mutable instrument and Hajiwo design mashup. I'm using op amps and I'm using the RP2040, and we are running code from Hajiwo, but I'm currently rewriting it. We're in the last stages of getting our first prototype up, and that involves reorganizing Hajiwo's code so that I understand how it works and I can branch out into more stuff. Because all this is a 3-volt microcontroller running at an extremely high speed that takes in a control voltage, takes in a 1 volt per octave, which could also be an audio signal, and then it outputs a PWM wave into a Sallen-Key filter that creates an audio wave. So we have a tuned audio output and we have tuned voltage inputs. So we can do a lot of cool stuff with this if we really learn how it works. No, I can't. Robotics and coding. Yeah, the best way to learn, in my mind, is to find something that you want to do first, something simple, and getting the kit that will enable you to do that thing, and maybe figuring out a couple different projects that are not complicated. They're like beginners projects. The first thing you ever want to do is a hello world, right? Getting into robotics and coding, and if you want to get straight into robotics, I'm sure there are plenty of resources for that. I don't know them. I have no idea. I do not know. And I don't know what level you're at and all that stuff. So yeah, it's a tough call. I don't know where to point people when they ask about that stuff. So what do we have? We have that switch, and then we have our mode select switch, which is 0, 2, and I think. Well, I think I organized, yeah, we organized all those modes based on the serial prints last time. Yeah, so that's not up to question. This is looking a lot more like we actually have a piece of software. So I guess the way that this software works now is we go through, we read the what is that, the analogs, right? We read the switches, we read the buttons. If anything changed, well, we run it through table set, which will set the tables based on like the mod value and the what do you call it? The mod value as well as the waveform that's selected. So the switch handler will punch us through a different waveform, but then we set the tables and then make frequency. What is that one doing? Make frequency. So that's what's taking the frequency table and setting that. And then in the background, while all this is happening, make the frequency, and then we do WAV, but we need to look at that because on PWM wrap, we have the IRQ clear. F is equal to F plus frequency, and frequency is set not by OSC frequency. Wait a minute. So we write OSC frequency. I guess do WAV is wherever we do that. Yeah, this programming is too much for me to be streaming. I should not be streaming this because it's a little bit too eclectic and complicated. But basically, we need to control what the Arduino uses for pulse width modulation, and we need to change those lengths of pulses in order to get our filter to create an audio wave. So it's like Flappy Bird, but we have to follow this exact path. And so what we're doing is, right now, I'm organizing all of my code. I'm organizing all the code so that it does stuff predictably, and I know what to edit where for when things go wrong. That's how coding works. Yeah, you go to learn something, and you discover that you need to learn another thing, but then you need to learn another thing, and by the time you've gotten to that thing that you need to learn, you don't know what you were originally trying to do. I understand that completely. I don't know. I think we're a little better than that here. I try to keep things nice and simple. This has gotten a little bit out of control. So when do we do the business of, well, mod 2 wavetable is what we've set, and mod 2 wavetable is what's coming out of the thing. On wrap is when we do this stuff. So what is, I don't think do WAV is doing anything. ADC, calibration, OSC freak. Where else are we using the OSC freak? Who has my OSC freak? Oscillation frequency. Find it, find it, find it. There. That's on wrap. Okay, F plus OSC freak. Is that, did I change that for some reason? Oh yeah, that's, so that shouldn't be, make that OSC freak. Freak is a little too, what are they highlighting there? Oh, frequency knob, frequency CV. Make freak, OSC freak is equal to freak, freak, freak. 800-544 freak. 1-800-854 freak. Freddy Freaker. Party line. Find. I feel like I've heard that commercial before on TV, but I wasn't reminded of it until Oni Plays did a whole thing on it. Freak SZ, freak table, set PWM frequency, freak pot, freak val. Okay, so aside from our, I think I have this sorted out, right? Yeah, float OSC freak, make freak, freak freak, OSC freak, set freak, freak knob, sieve freak, pot freak, make freak, freak freak, OSC freak, freak, OSC freak, freak freak, freak. Okay, cool. We got all our freaks in line. Whew. So I think the do WAV is actually not happening because it's happening always in the background. It's an interrupt that occurs when we count up to the maximum value of that oscillator. So what we have to do is get rid of do WAV and get it out. Get out of here. Just get it out of here. Just get it out. Don't want to see it anymore. These are so weird. So 4 if else if else if else if else. So if 4. We're missing a bracket. Tasting menu tree a la carte. That's, wait, what happened? Champagne fountains, caviar mountains. It's just a start. Oh, wait, we go back one on that. There we go. So it's mod if 4, etc. Okay. And then this one comes back. Give it a little bit of breathing room. I'm a big dumb guy and I need to be able to see everything on this program. That's why we're putting so much service into organizing this. There's probably some better Oh yeah. Hey, thank you. Thank you for stopping by. Are you programming the modular synthesizer to produce different sounds by turning the knob? Well, yeah, essentially, but that's not as simple as it is. Pulse density modulation. I guess that's what it is. Yeah, it's like energy modulate. I get everything is energy, but it's like modulating the amount of energy into a filter in order to create a wave. That's sort of what's going on. That's what Mod 2 wavetable represents. And we're scaling it, we're moving it all around in order to make sure that our stuff does the proper stuff. Yeah. Yeah, because here we make the waveform in voltage, and then here we apply the modulation from the CV or the knob, and then here we make the end wavetable based on how the PWM should react. Actually, no. Here we populate it based on the type of feature that we're running. So are we running AM modulation, FM modulation, or wave folding? And if we're running wave folding, that just means it mirrors it on the number lines based on how mod scales it. But then in order to output it, that's all the way up here. Okay, there's do-wav. We don't need that. Yeah, that's not what we have. I now understand how this code works. So then when we do the business of making the PWM during the PWM cycles, there's an interrupt when it wraps around. And so when it wraps around, it creates its next iteration, which PWM clear the IRQ, gets the IRQ ready to run. Then frequency is equal to frequency plus whatever OSC frequency that we've calculated based on the frequency knob and CV. If F is greater than 255, F is equal to 0. And of course, it's also getting the, yeah, here's where PWM set channel level per slice number, PWM channel A, and then it sets mod 2 wavetable of K. For some reason, it's then adding 511 to it. I don't really understand that, but that does it. That apparently sets our PWM rate. Oh, God. You're just walking down at me singing. Okay, so do-wav we don't need. And then test prints is just printing out various variables that represent everything. And I probably don't have the right variable names in here anymore. We haven't done the LED engine yet. I guess we'll just leave that out for now. So the mod CV and stuff we're storing differently. I really need to reorganize where all these programs are now. And we're going to run into about 1,001 errors, by the way. This is just how it's going to go down. Just how it's going to go down. It's going to go down rough. In the jungle. This doesn't need a space there. I keep confusing myself when I see that. This feels like it could be more compact, but I guess I have to leave it alone. 0 to 255, 0 to 255, and then within that, if it's greater than and less than a certain value, it's just weird the way it's doing it. I probably would have been a little bit more straightforward in it. I like stuff like this that's like nice and simple. I like my simple statements. Mod knob and mod CV. Lowercase v. Wait. Lowercase v. Where is it? Lowercase w. I gotta look at all my variables. Lowercase v, lowercase v. Okay. Camel case has been preserved. Boy, oh boy. That would be... Wait, but that's mod CV, and the other one is that frequency CV? I think it is. My freak CV? Yeah, freak CV. Freak. Is it knob? Freak knob. So wait. Mod CV. Volt per octave CV. We can keep that label. Frequency knob. Mod pot. Mode switch is mode SW. And then octave switch is oct SW. Bouncer button debouncer.fel debouncer.feel. Whew, okay. Yeah, demodulating is that might be the beast, is if I try to take audio input and do weird stuff to it. Fancy-o-scope, yeah, I've always had the fancy-o-scope. No, I haven't always had it. I had it since my birthday. This is our first year with a new O-scope. Let's save this and let's just see if we can run the compiler. Let's see if we can compile it and see what busts up. Because there's some stuff that I assume... I'm going to get a glass of water before I hit compile, actually. I'm going to mute you guys. I'm going to put on whatever, which I think is later alligator music. All right, I'll be right back. All right, I'm back. Let's compile this. Let's compile the beast. Yeah, the glare on the scope is pretty extreme, huh? Bonk, and then... Oh, that's the wrong one. Boop. There we go. All right, so, I don't know. My code should be okay. We've done everything but the LED code. And so the LED code, I kind of want to get this thing back in. The rhythmic chanting of freak really brings back my school days. What are you talking about? Okay, so on review, the code does a bunch of stuff, but the whole point is that we're trying to calculate a wavetable in the end. So we have various things that affect the wavetable, and then we have a frequency set that we're creating from the very beginning of the code. We know that works because we've gotten a sine wave to come out of it. The sine wave modulation is fairly straightforward. Basically, it's only doing one step. So what the FM wavetable is going through a series of equations that take into factor the value of mod. And actually, Ben Gizmo was so gung-ho about this software that he came up with inside of a Desmos thingy-majig, and I guess it's still valid. He went through and he made the equations in a Desmos thing. So you can do the modulation knob from 0 to 128 and see what that actually does to the waveform that outputs. So we know that this stuff is all valid, and we know it works. So technically, if my code is up to snuff, it should run this thing perfectly. So let's just see where our first fault is. Yeah, the website I can share with you guys. We're just going to get an error over here, so let me just do this and go over to here. And this is Ben Gizmo making this. It's probably Ben Gizmo, but for some reason I'm like, Ben Gizmo. I don't know why I have to say it that way. It's like, please feel free to correct me on my pronunciation of your screen names. I will continue to get it wrong. I make no promises, but... First error. AM timer. Oh, AM timer doesn't need parenthesis around it. Oh, it's nice that it actually it found that. Hey, old AM timer, how you doing? That's actually, I don't know if that timer is going to fold over. That might actually cause an issue. We need a timer that's agnostic to the wraparound, and in order to do that, we actually use subtraction. So if that's less than or equal to micros, what if it's greater than or equal to micros? If AM timer plus mod is less than or equal to micros, we iterate through K, and we make mod 2 wavetables equal to wavetable I times AM mod. I've explained it 100,000 times. I guess I'll explain it again. We're making a voltage-controlled oscillator. This is the 10th stream that I've been doing this exact same thing for. We've built the hardware. We know the hardware works. We've tested the hardware. We've figured out what the scaling values are from the hardware from a serial printout from the RP2040. In order to make the Sallen-Key low-pass filter do its low pass, basically, what we're doing is we're adding energy into the filter. And we do that with a pulse width modulated signal. That's this thing in the background. So the more positive it is, the more positive our waveform is. The more negative it is, the more negative our waveform is. In order to control that, in order to run a sine wave through that, you have to use the sine function. You have to calculate it based on the timing of the slice of the PWM, because the PWM is split into 1024 increments, which can either be high or low. So it'll be low for a number of increments, then go high for a number of increments. So the more high we make it, the more higher voltages. The more low we make it, the more lower voltages. This is all based on code from Hajiwo, who makes cheap modular synthesizer circuits. And this is a huge code rewrite so that I can understand what the hell is going on. And so we are at the precipice of actually running the code. I mean, I kind of understand it. I guess I fully understand it. Some of the derivations of numbers I do not get. And maybe if I look into it a little further, I would understand where these numbers are coming from. Whoop! Bum bum bum. Qubits. Qubits. Oh boy, we gotta wait. Oh, it's not supposed to be there at all. Bonk, bonk. EEPROM L is at 0. I don't understand PWM CDIV. Do we use that? CDIV. Slice number, set clock division. It's on a set to 1. It's all the way at the top. Hold on. System clock over resolution plus 1 times frequency. Dunno. Guess we'll leave it alone. Ah! Table setup was not declared in this scope. No! Table. Actually, we can just scroll down to it. Wavefold, AM, FM, saw, square, triangle, oct, saw, wavefold module, FM module, table setup, table setup. Table setup, table setup, table setup, all the way up here. I did not mean table set, you jerk. That's table set. Wait, I shouldn't be running table set every single loop. No, I should, because that looks at, yeah, because the mod, technically our mod can change when we read analog. Table setup. It's the same. It's the, wait, but that function is the maybe the table. Is there not a semicolon before table setup, and maybe it doesn't understand? Where's table set up? Table set up. Table set up. PWM setup. Table set up. Void here. That seems fine. Why are you not declared in the scope? That was totally declared and very much fine and normal. Can it not run in setup if it's... No, yes it can. I don't know, maybe something weird. Let's just see what happens. Ah, again. How come it's fine with table set, but not table set up? Can I just tell it no? I'm totally fine. Table setup is totally a function. It sits right here. FM modulation, 511, end of the bracket, end of the else, end of this, end of that. Oh, here we go. No, wait, no, that's fine. That's valid. That's totally fine. That one's closed too. Let's do octave setup in line with what Hajiwo called it. I don't think I need to do that. I've never had trouble with that anyway. It's oct set up, right? I'm lost. Oct set up, yeah. Well, I mean, I guess we are just getting to the functions that I have in here. But it didn't say anything for table set. It was totally fine with table set. And then it says, it sees table set up, and it's like, wait a minute, do you mean this? Maybe setup is a some kind of a thing that it like looks for. That doesn't make any sense, but no, I don't know, I'll just try it. Everybody has semicolons too, so it should be fine. Let's check again. Let's just see if it happens again. Told you this thing would be a beast. Sometimes I have values down in the code and I really shouldn't. All the values should be up top. But you can't help it when you do this much calculation. Oct setup was not declared in the scope, but table setup was. Oh, there's other errors. Wait a minute. Oh, there's an error somewhere else and it's cascading into it. Let's go to the top of our errors. Oh my goodness, there's a lot of stuff actually. There's actually a lot of stuff going on here. Wait a minute. Somebody doesn't have the right amount of parenthetical thingies. Oct setup was not, PWM setup was not, test prints, switch. Everybody wasn't set up. Up us. Let's just check our parentheses and make sure that they all close off. That one's good. That one's good. Good. That's good, in spite of it not looking good. That one's 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 good. Good on that. There we go. AM's all effed up. Bada bing. So that closes that off. This one, if the bouncer fell, that's not supposed to be there. That closes that off. This one should close off the whole thing. Oh, so we need one here. Just like that. Check you. You go all the way to the beginning of the function. You go to the beginning of that for loop. You go to the beginning of that for loop. You go to the if function there. Good. This one, that one, good. This one, whole function, good. This one, whole function, good. This one, whole function, good. Whole function, switch, should be bop, and then bop. Control S. Hold on, let's get through this. Are we done saving? Nope, not yet. Okay, that's the whole function. This just runs everything. Yep, okay. You, correct. The only other errors, the big errors that I see happening here are going to be with types. All the different ints and floats and stuff. Okay, so we should not have a scope error now. Let's check. Yes, yes. Bonk. Mod SW. Oh, mode switch or mod switch? No, it's SW. Oh, really? SW octave and SW mode? Should be mode SW, shouldn't it? And then oct SW. And then oct SW is coming in as octave, I believe. So I need to actually edit the equation somewhere around here. During octave set, maybe? Where is the octave set? Wavetable and mod. There was a multiplicative. There's oct underscore switch. Oct SW. That's during make frequency. Knobbed V scaled oscillation frequency 256 times the qubits. Okay. Mod switch. break, good. Ask freak is, we're using that same one. And then oct SW, and then mode SW, and then waveform number, and then previous waveform number. So let's go ahead and check this again with some variable weirdness just because of all the stuff that I've kind of thrown in. We're getting down into the nitty gritty though. We're getting there. I tried moving a function in the old code of mine at the bottom and it spit out the same error. Yeah, it's you can say you sometimes have to put stuff up. Oh. Mode switch. Yeah, there's some things like where like you do structures that you have to do those above and things like that. I'm used to the Arduino method where you put all the functions down below everything, but a lot of C code and like C++ will move it up above. WF, oh, waveform. Where's that waveform function? Wavefold is WF. I forgot to do that. Let it save, 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 let it save. There it goes. Check. Let's go. I want to actually start doing stuff because like we're not getting viewers with this. Damn it. Num modes. Number waveforms. I know you're a viewer and I appreciate you very greatly. Num waveforms. How many are there? I think it's 8. We'll put in 7. Yeah, num waveforms is 7. What is AM doing with the amount of, because waveform 0 through 7, AM doesn't do anything with waveforms. Yes, it does. It does this. And then FM does this. And then wave folder? No, wave folder does this, 0 to 7. AM does this, FM does this. Yeah, okay, so it's 0 through 7. So num waveforms is it greater than num waveforms? So yeah, it has to be 7. So it needs to stream themselves debugging viewers code and they cannot stream until they can't end the stream until they compile it. That sounds awful. That sounds terrible. Because people just put in, you know, crappy code. So if the waveform is greater than number of waveforms, so it can equal 7, but then when it gets to 8, it gets set back to 0. Check it over. Check it over. What do we got? I mean, I'd probably end the stream with a first-person submission. I'd just be like, this is junk. Delete the whole thing. Stream over. I expected a semicolon. How dare you? Oh, okay. These don't have semicolons. Those are complete lines of code. Any others that are missing semicolons? Semicolons. Those got them. Those got them. Okay, check it over again. Boop. don't even know the lyrics and the song's stuck in my head. Compiling. Damn it. No, this is semicolon. Where'd you expect it? Why? I put it in there. Oh, whoops. Oopsie daisy. Poopsie doodle. Poopsie daisy. Ah! I don't know why I mix those up. Why is that one the most messed up one? Probably because it's the most complicated. Oh, right. This wouldn't have run at all. Oh, God, I did it everywhere. I messed it up. This is what we used to do with spreadsheets. You learn to hit a certain sequence and just do it as fast as possible for like 10 minutes to correct a giant spreadsheet. Clearly, I'm not the type of person who runs either, so. Here I did them right. All right, let's check it over again. Boop. See what the next error is. So this is the part that I like to show that a lot of people kind of rob me of by correcting my code as I go. It's hard because, you know, having people that are engaged with what you're doing is really important, but letting them tell me to just like, you know, oh, you missed a semicolon. Like, I don't like that. It's nice to have, but at the same time, FM module is not declared in this scope. Oh, it's now waveform module. Waveform. What is this one doing? The AM one. That's all changed. And this one's FM module, but I'm actually gonna call that FM module now. Or rather FM mod. Because they don't have the other ones anymore. It's now WF mod. So this one's now FM mod, and then my function changes to FM mod. It started with a silly name and moved on from that. Check it over. Let's go. Something about the EEPROM flashed up there. I don't know what the deal is there. Learning a little through observation. That's good. Yeah, eventually you'll... FM module? No. FM mod 1. Waveform module. Oh. Waveform... WF module is not declared. Semicolon, 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 semicolon. It's not semicolons. All right, FM mod of thing. WF module. We'll call these module just to be consistent. That's FM module. Saw square blah 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 blah. FM module. And the one it didn't find was WF module. Well, last time this happened, it was because of parenthesis. So where are my parentheses breaking down? You good, you good. You're good. You're good. You're good. You're good. So over here by FM module, we have this one, because that's void FM module. Oh. No, it's still FM. It's WF module. It did not understand. And I tried to guess on a thing. Yeah, it looks fine. Something could be breaking all of them. I don't think it's a non-declared on the scope. Unless I misspelled something, but WF module seems alright. Isn't it better to replace the functions with the find and replace tool? Yeah, it is. But I'm not, I mean, I know my code. I know where I'm using this stuff. This is one big for loop. Then this is something. That is something. That is something. That's something. That's something. And then this is 2 lines. That's the end of that. And looking at it from the other direction, those are fine. Nearby, that one's good. That one's good. And then these 2 are internal. And then this one does the follow-up calculation of everything. Okay. Yep, that's still good. Still good. Still good. This is throwing me off. Wait a minute. The fart button, its certificates ran out, and so I took that as an opportunity instead of fixing all the certificate stuff, because there was some update to how security stuff worked. Instead, I'm going to roll that into a Node-RED project. We'll work on that soon. That's a little bit of work, but that gets us closer to burn the subs as well, because that allows us to troubleshoot, well, to get a Node-RED setup, what allows me to have, what do you call it? All of the names of subscribers go into Node-RED and get vetted out from there. Oh, it's easier. Yeah, it's easier to follow the cursor. I'm going to try again and just see if it works. I don't know why it's like having all the declaration issues. It should be fine. Everything should be bracketed in. I checked. I didn't check everything. And that's where it breaks, where you don't check. Yeah. This has been work. I didn't expect this to be so much work. I thought I was just going to be able to throw code onto the things, but the code is just not that well put together. WF_module is not declared within the scope of AM. Yeah, this is actually, if we could have done this part sooner, it would have been great, because this frustration and troubleshooting is also part of the process, and it's an important part of the process. I feel like, all right, I feel like I need to check my brackets from the top. So we're going to check it from the top. That means I can also fix stuff like that. That comes from Hajiwa's code. Void setup should go all the way to the bottom of setup. That is correct. Void, everything in there is contained. Void loop goes to the bottom of the loop. That is contained. Loop. What the hell? Set up. Okay, so setup is contained, loop is contained, on PM wrap contained table set switch, read analog contained, make frequency contained, switch handler contained, everybody has semicolons, button handler contained, if the bouncer fell contained. I don't think I need to put a semicolon after that. If waveform contained, EEPROM is a semicolon, void waveform. No. Void waveform, yeah, contained. Semicolon, contained. Oh, wait a minute. Yeah, debouncer fell, and then switch waveform. Yep, that's good. Calculate mod 2 wavetable. That's mod wavetable, actually. I have a glass of water sitting right here. I need to move it. Calc mod 2 wavetable. Everybody on YouTube skips through this part because most people think it's boring. Yeah, that's the thing. And like, that's one thing that I've seen happen. Oh, my neck just cracked really hard. I've seen happen a lot is where everything is perfect in the world of YouTube, and it's very frustrating to watch because you'll try it and you'll run into a weird error, and it's something that they probably have worked out already. So I show everything, and it's to the detriment of the number of viewers of this stream. I would like to be a little bit more successful on this platform, which is why I am co-streaming also to YouTube. Hopefully that brings in some people. We've seen a little bit of engagement from YouTube, just a little bit. Not as much as I would like, but that's okay. I'm still getting those VODs up. I have about 180 to go, which is 180 is a significantly lower number from 350. So I've done a huge amount of work. I'm currently scheduled up until April, I think, 3rd. Ow! I hit the camera with my head. Up until like April 3rd with uploads. So if we can get this thing to actually like recognize this crap. I don't know why it doesn't like WF_modu. I don't know why I'm naming my functions with underscores as well as camel case. I really need to be more consistent about that. Maybe someday I need to go back through all of my code and correct that. WF_modu. And we just need to make sure. Brackets, brackets. Brackets on that whole thing. Good. That's a mini bracket. So we get bop, bop. And then that's just a function in there. And then boom, we get this one. Boom, headshot. Wavetable of IAM mod. AM timer is equal to micros. That closes that off. This one closes that off. That one closes there. FM down to there. Waveform down to there. Saw. 4. 4. Square. Triangle. Triangle. Octsaw. Octsaw. Really? I try to be as readable as possible because, you know, hey, it's very public. I don't get how people write code that's not readable. I don't get how you get to that point where it's, you know, it's very tough to read code. I don't know if this is messing it up. I don't think it does. I think I can split that off. I just split that off because it splits these out into their own little things. I think it's okay to do that. This is where I learned that it's not. That's the whole function. Then we've got the for function that does the 256 rounds. Then we've got the 2 line there. That's 1 line, 1 line, 1 line, 1 line. I'm looking at what I'm looking for is the other little bracket that highlights, because it'll tell you where it thinks that this bracket is closed off. It does it with parentheses too. We found one error, but I don't know what this one could potentially be. So I'm just making sure that all of my stuff is closed. And it is. So what the hell? Mod B 128, blah, 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 mod C. Why is it pointing me towards mod C? Cool FM8, A, A1, B, B1. Oh, there is no C. Oh, I need like a whole nother line in here? Whoa, wait a minute. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 4, 6, 8, 9. Oh yeah, so we need the C's in here. Whoopsie daisy. All right, let's double check that. Maybe that's what broke it. I don't think it did, but that's another thing that's broken that we needed to correct. Okay, so WF module was not declared in this scope. FM module. Where's WF module? WF module. Int mod A, int mod B, mod B, mod B, mod A, mod A. Mod B rolled into mod A. Wait till I find blah 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 mod A. WF underscore modu int mod A int mod B. There it is, just right there. Usually there's some kind of like an error before it. Case 1, WF modu. No, it doesn't. Well, according to, okay, so I guess I can't totally rule that out. Does it need to be before? But in Arduino, I was able to put all the functions below the code pretty consistently. I mean, it's not calling anything else out. So I don't understand why that would be. I mean, I can move it. I could always move it, but I don't think that's fully necessary. But in Arduino, typically, I mean, look, if I go to code that I already know works, right? Like Linduino. Actually, I think this one's a very big program. This might not be the one to use as an example here. Yeah, this is the master program for the LIN bus. Actually, this one's just for LIN bus, so this one's a little bit more easy. I do all my defines. I do some settings up here that I want to frequently change. I have addresses and constants. I do some tables here in order to represent the various sensor values. I set up in the setup. I do all my pin modes. I do all my initial pin levels, and then I start up serial. Then I have a loop with a bunch of very simple programs in it, and then I have all of the programs that run, and they do all of this stuff, right? But all of these functions are down here below everything. They're all down below my code. There's a lot of function stuff going on down below. So the question is, like digital outputs, I have wheel outs, shift outs, and pedal outs. And those are being declared below the code. So there's no reason why referencing a function here shouldn't work down here. I have structured other programs in exactly the same way, where it is referencing something below it. What up, Pyro? So we're trying to get our code to work, and right now I'm having declaration issues. WF modu in line number, what was it, like 13? Yeah, here it is. Line 255, huh? WF modu was not declared within the scope of void AM, but yet down here I have WF modu and all that it contains. And we just verified that a different program does not need it to be declared ahead of time. I know, but it needed to be addressed. So a rogue semicolon or a rogue curly brace might be default for this. We did a curly brace search and I didn't find anything. Yeah, I wonder if, but for default values, if you declare incident, it should do the thing. Because like I have it set up for int mod A is equal to 0, int mod B is equal to 0. So if mod A and mod B are equal to 0, oh, then doesn't it do it? Does it not do anything? Hold on, wait a minute. No, that needs to equal to 0. Because if this is equal to 0, that means that it's just sine of 2 pi m pi times I over 256. It's just a sawtooth. But I mean, if I invoke a 0, maybe that'll, maybe then it'll be happy with me. And I'll finally be popular. Switch of waveform, case of 0. That's commented out, so might as well not even be there. Bah! Default argument missing for parameter 3 of void FM modu. Bool int. But if it's missing, then it should just go in there as a 0 as a default value. Oh, I see. So I need to declare those anyway. Even though I'm not actually giving them. It should equal 0 even though I don't need them to be default values. That may be part of what's going on here. If you give one thing a default value, you have to give them all a default value. So then that becomes equal to 0. I have a feeling it'll just give the error further down. Case 1, waveform modu, break. Fmod 1. Why does it think it's all Fmod 1? That's weird. .3, 7.3. Wait a sec. Why is there so much space over there? Where are we? We're down. No, we're up here. Oh no, that's just weird spacing. Yeah, okay, so those are all closed off. Close this. AM there. Strain is there. Okay. I shouldn't need to move it. I've referenced functions below other functions often. I do that all the time. Let's check it again now that I've changed that AM thing to equal something. Let's just see what happens. Push comes to shove, move it. I mean, that's just part of the process. But I shouldn't need to do that, because I haven't needed to do that in the past. There have been some weird exceptions to that, but that's still doing it. Bastard. But I have an example right here where I'm actually, or no, not here. I pulled up an example earlier where in a function, I am referencing a function that's below it. Watch, it compiles now. It's totally happy with me. It's going to pull up the other one that's still down below. It's going to make me a liar. Well, we found a thingy before a thingy. Wow, what's going on there? That was the one that I referenced before. So I guess you guys are right. The example that I pulled up, where is that? Do I still have that open? VCO only. No, I don't have it open. Let me open it up again. It's in recent. This one. Oh, you're saying, okay, so it is a different form. A function with no argument is a procedure. Boy, this is the first time I've heard of that. Because, yeah, what was I doing? I was doing, like, get bits. But that apparently, according to you, is a procedure. I don't even know if this one's below it. Let's just take it as an example. Yeah. Get bits is referenced line 182. And then it's declared all the way out down here. And it's got a return on it too. So it's just strange that that is happening that way. I guess if you put arguments in it, it needs to be declared ahead of time. Doesn't make much sense to me. But let's take FM modulator and move it up as well, if that's going to be the case. I do need to organize these a little bit. So there's, what is that? It's FM and AM, waveform modulator, waveform and AM, no, waveform and, damn it, waveform and FM. And so in waveform, we're referencing waveform. AM, we're not referencing, AM, we're referencing waveform modulator again. Is that correct? I think it is. FM, we're doing the FM modulator, and that's direct, but that one's sitting up above. This wavefold modulator is not quite correct, but whatever. Wavefold is what's happening down there. It's just the FM is creating the table. It's my naming for these things is probably not exactly accurate, but let's check it over again and see if we run into the error now. Now that we've declared the things that have declarations inside of them. I did not think you had to do that. Although we have had to do stuff like that in the past, so maybe that's when that was happening. And chat just got so frustrated with me they didn't think to correct or explain it in a digestible way. Or they did and it didn't take. That's usually what happens. A little bit of renaming and reorganizing would probably do this thing well, but let's just see if our code works now that we've gotten it to compile suddenly. Okay, so plug this thing in, then we check to see that the port's there, COM4, good, and then we upload. Let's see what happens. I'll bring you guys over here so you can see it initially. Sink or swim. Resetting COM4. Converting to UTF. Wrote. Bytes. And nothing. And nothing. We're going to have to use some serial prints for this. Wait a minute. But we do get PWM output. Where are you, Salin key filter? What's going on there? Well, our PWM's running. It's probably caught up on something right now. Yeah, it looks like it's running at 0. So if I try... Ooh, wait, something happened there in the middle. Ah, look at you. Frequency, 140 hertz. No effect. Whoa! Hey, how about that? Check that out, chat. I'm affecting the frequency. I'm like a god. Here, let's move the scope down. Oh, cool. Very cool. Where's scope? Scope. Suck. No. Where the hell is this thing? Oh, there it is. Scope. Yoink. Well, so when I move the frequency knob, the frequency changes. So yes, this is what it's supposed to do. Of course, we'll have to measure it a little bit more completely, but why is the scope so slow? Probably because I'm zoomed way in. Or out. It's holding more data and displaying it. Actually, this seems to be working in blocks and not... Probably... Oh, did the integerization of this cause it to work in discrete? I think it's working in discrete bins. Oh, and then it blows up when I do that. Yeah, it's working in discrete bins. That's not good. Let's change this. Again. No. Oh, there's a different one. That doesn't do anything. Okay. Different octave? Octave, octave. Yeah, that works. Okay, that one works. Oh, this one does seem to have different waveforms in it. The mod isn't doing anything to it. We're still discretely changing. See, that changes. Mod still doesn't do shit. Discrete bins. So let's go to a different encoding scheme. Dead. Okay. Mod ain't do nothing. Oh, that's a wave. So, sort of. Whoa. Techno dancing. What is this thing doing? What is it supposed to do? I don't know. Oh, cool. Amplitude modulation. Wee, 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 wee. That still changes the frequency. I think, does AM doesn't use the waveforms, does it? Go down an octave? Go up an octave? Sorry, that was down an octave. Wait, this is down an octave. That's up an octave. I might want to reverse that switch then. So the modulation, or the mod doesn't appear to do anything. Of course, as it is programmed right now, it should go from 0 to the top of the range. And, oh, well, the CV coming in is 0. I guess that doesn't change it. The frequency the frequency knob does change the frequency organically in this one. You can see it doing small increments. And that's in AM. I guess that one's AM. This one's FM. There's a frequency. It goes way low when you move it to the bottom. But then our modulation does nothing. Press the button to go to a different mode. Try again. Nothing. There's the one that's different. Mod still does nothing. And this is in bins. It's not... See how it's moving an entire thing as I move the knob a little bit. So that's a number issue. We'll have to use serial prints to figure that one out. Nothing's going on there. Just max out the modification and see what happens. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, okay. And then the wave folding mode. How now, brown cow? Wave folding mode has just pretty much locked out. Wait a minute, there's a frequency in there. What is that? What the heck? Wave folding is totally broken. As are our various types of waves. So we need to deconstruct this a little bit, and we need to take a look at what's going into the stuff. Yeah. All right. So we need another set of test prints and another set of variables that we're going to look at. Yeah, see, it's maxing out, and then it's just creating a little noob every now and then, a little nubby. Turn the frequency all the way down. Yeah, it doesn't matter. All right, we got a little bit of growing to do. The octave switch works. What the? Oh, that got all weird. All right. Oh boy, where do we even start with this thing? So FM isn't doing anything. That means that our math is probably all screwed up, which probably means these need to be floats all the way through. So let's floatomerize all of our variables. Well, actually, if the mods don't have decimals in them, these can remain int, and the A's, B's, and C's can be floated. Since they are the result of a sign value. Floats are big numbers. I'm used to doing very compact microcontroller code that runs very nicely. I'm like the modern version of the machine language coder, where you're just like, ooh, why would you do that to yourself? I can't believe moving them up above was what fixed it. I don't like that, because I'm used to being able to just throw stuff down below. Yeah, it looks like these should be also the A2s. At least, wait, hold on, that one doesn't use it. These are not decimals. So the original numbers can be ints, but the original ones that I'm putting this into, with the equal sign, those need to be floats because we've got decimal numbers going into them. So although they're an integer, when it gets evaluated, it's going into a float. It'll probably, maybe the compiler will deal with that. I don't think if we cast one of these as an int, if we put it through the sign function, I think it returns a float. Let's check. Let's check what arduino.cc says. We have answers to these questions, and they're at arduino.cc. I have a lot of windows open that I don't need open. Everybody go away. Go away. Go away. Go away. Go away. The then gizmo thing we will put with this window. Put it up at the beginning. That's our pinout. We're actually pretty good on that. We don't need that anymore. Hajiwo stays. The notes stay. Buchao, gone. Your main write-up can stay. Braids, we don't need anymore. Don't fear that's the same article as before. And then here's Arduino reference already. Full circle. All right, so back to the reference and sign. Squirt. That's disgusting. I could probably use some libraries to do this stuff better, huh? You use them in random order just so long as the prototype is declared beforehand. It's so weird though. That's strange. I'm used to Arduino code structure, and I know a lot of like the other microcontrollers, when they program them, they put all the function declarations up ahead of the main code. I just didn't know that if you define values inside of your functions, they become something else and they have to be placed before where they're used. Oh, I see. Yeah, that's too weird. I was just used to saying like, here's this thing and this function and here's this, and then you move down as you scroll by. It's just new to me. That's all. Sign, trigonometry, description, calculates sign in rad. The result is between -1 and 1. Sign is rad. Radian. Allowed data types. Float. So returns the sign of the angle, data type double. Oh, do I double it? I don't know. Doubles are huge though. Oh, it's only 4 bytes. I think I can keep it floats without making it a double though. If I float those and I keep those as ints, those are used for base calculation and the floats will be placed into the stuff. So maybe that's okay. Let's just check to see if that helps it, and then we'll have to get into serial prints in order to get specifics out of the program and figure out what the hell's going on. We know the switch engine works though. My switching engine works because you saw me click through it 7 times and that slightly varied wave came out. But let's see if this gives us a nice smooth range of frequency values. And we're back. I thought it was the scope, but it's really the knob that's doing this. Yeah, it seems to be done in discrete bins. Oops, that one breaks it. And then mod does nothing. Save it to just changing the waveform does nothing either. There's the slightly different one. That's our weirdo. Yeah, it's discrete still. Try this mode. That mode is still broken. Nope. That seemed to do something, but there's no data there. Okay. Bonk. And then bonk. Whoa! Wavefold my ass. That actually kind of looks like it's wavefolding. Whoa, look at how discrete those jumps are, though. I mean, weird stuff is going down. Strange things are afoot at the Circle K. Oh, now we're back to like a kind of a normal mode. I mean, something's doing. It seems a little funky. Oh yeah, because it's amplitude modulations, right? I don't really think that's doing anything. The frequency is adjusting what seems to be organically. The rest of the wave type is non-existent. 3, 4, 5, 6, 7. Yeah, nothing. I have no idea what's going on, but it looks cool. Yes, yes, sir, it does. All right, so things are still kind of messed up. You know, it could have something to do with this. It could have something to do with the typing. We need to find one thing at a time, and we need to work on it specifically. So what I want to do, first of all, we need to reverse the switch. So the mode switch is going to be 3 minus whatever. No, that doesn't really work, does it? I need to reverse the mode switch. So if I do... Well, if I just do... No, that doesn't work, because then the numbers come through differently. If I reverse 1 and 2... No, wait, I don't want mode to be... No, I want octave to be reversed. I think that just means changing these. So one thing at a time, let's upload that code. We're going to be uploading a lot of code until I get this right. And if you guys so desire, I could put this up on GitHub when we're done. I'll have to log back into GitHub. I haven't uploaded anything to GitHub in a long time, and I have lots of code that needs to go into GitHub. Lots and lots of code. Okay, so now if we go to a mode that actually has frequencies on it, like that one, adjust it so that it's visible, even though it's happening in discrete banks, I can go boop, boop, good. And that lowers as the knob or the switch goes down, the frequency goes down. I guess we're not going to view PWM anymore, huh? I could hook back onto it, but it's a little annoying, although it does give us an insight into more of what the thing's doing. But for right now, I mean, I guess we have frequency output, so. Okay, all right. So, serial prints. We have access to every single global variable at our disposal. So what we can do is we can get rid of these guys. Well, actually, I kind of want... Why am I doing that here? I don't need that. Serial print button bouncer fell. Don't need this, don't need that. I actually don't need any of this right now. Although I could display some of these values and see what they're doing for the frequency. But I should probably look at what the frequency value, what the freak is, and see what that comes up to and why is it so discrete. But we should do one mode at a time, right? So wave folding doesn't do a goddamn thing. So maybe we should take a look at wavefold and see what's going on behind the scenes in wavefold. Although that's a little complicated, maybe we can get a little bit further in. FM works. AM. I thought we had AM working. I have a feeling this is a type issue. Oh yeah, here's one mode of AM works. Maybe we should display the mode. That's one thing that we should definitely look at. So first of all, we'll just do mode switch. And then, oh no, not mode switch. We need, well actually the mode switch would be useful to have. So let's go ahead and do that one. Mode switch, let's do the mode number, the waveform number rather. So we'll do WFM waveform is going to be waveform. So mode switch and waveform. Let's save, or let's, no, I hit the wrong button. I meant to upload that. So we'll upload that and then we'll take a look at it on the serial chart. Hey, if you're working on cool projects and you want to talk about it, feel free to join my Discord. That's where I am. That's where I hang out. And we have all kinds of weird projects that people are working on in there. It's a lot of fun. Big stretch. All right, let's upload that as soon as we can. Come on. It's gonna compile it again, isn't it? Dump prefs, etc. Yeah, there's your Discord. I'm tired today. I just was up late last night. I stubbed my toe on something and I don't remember doing it. I don't know what happened there. If I was sleepwalking, maybe I got really, really tired. Okay, so we're looking at the serial prints. Oop. Mode switch is at 1, 3, 2. So 2 would be the top mode. 2 would be the waveform thing, but what we'll do is, we do on and when thing, we have stuff. Mode switch, case 2, waveform, case 3, FM, case 1, AM. So there they are in order now. So 2, 3, 1. Mode switch 1, wave folder. Mode 0, mode 1, mode 2, mode 3. And I guess I should probably have it tell us what the frequency is. There's some weird stuff going through here. So yeah, let's start off looking at our scaled outputs. So frequency knob, frequency CV, mod knob, mod CV. But what I want to do is then look at what the overall output of this stuff is. So where are we? 4 in I is equal to 56 mode. Wavetable device side, blah, 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 blah. That's for WF mod U, and then we have that mod U. And so if we run WF, we have mod is equal to. So if I serial print mod, that should give me a frenetic changing number. Yeah, I guess I could serial print mod here. But then it'll, no, you know what? No. Because the serial prints are after all this stuff runs. So we're overwriting mod once, and that'll be our final value. So if I take that, then we do serial print mod. So I can't type with this glass of water right there. Let's spill that on everything. Serial print, and then we'll do wall. Actually, it's the first one, so it can just be mod space, quote, parentheses, semicolon, comment it out, enter, serial print mod, just like that. Try typing around an affectionate three-legged cat. My doggy likes to be at the front door. I wish she would hang out while we're doing this stuff, but I'm too shouty, I think, for her. Who the heck is that? Dabson 1. Do the thing that 2 does the stuff. Yes. What? Yes. Oh, and maybe we should also get our frequency out of this too. So where are we finding out what our frequency is? Our freak. So we do the business of the knobs, and then we have ask freak. So I'm going to take ask freak because we run make freak. So I just take that variable, serial print. Oh, we'll do it after. No. It should be the first piece of information. So this is space wall space. So serial print freak, and then serial print ask freak. We're going to take a look at the oscillation frequency, the mod value, the mode switch, and what waveform we're on. I clicked the wrong one again. You get out of here. Oh boy. And then you upload. We're going to tweak all these little things until we get this thing finally working. So we'll take it one at a time and just see what the values look like and see if we can't come up with a way to get it working again. It's most likely ints and doubles and floats and all that stuff that are going to be affecting us. I thought you uploaded. Oh, it didn't upload yet. Upload. Come on, buddy. Candidates. Candidates. Compiling, compiling. Blah, blah, blah. And there we go. Frequencies 0.55. Whoa. 4, 2, 1, 0.55, 0.14. Why is mod changing? Mod changes when I change the frequency. This one does nothing. Okay, there's our first one. Wait a minute. How the fuck? Okay, all right. I see what you're doing there. I'm picking up what you're putting down. Let's take a look at what's going on with these knobs. So, knobbed, frequency knob, frequency CV, octave scale. Osc freak is what? Is that a float? Yes. Okay, so that's appropriate, but it's jumping all over the place. It's yumping. So, hold on, where that thing at? My code is all over the place. I don't know where it is. It's so disorganized. And I can't collapse it like you can with other compilers. If I did a different one, I could easily collapse things and it would be fine. It's fine. It's fine. We're in hard mode. Freak knob, freak CV, mod knob, mod CV. Freak knob and freak CV are being added together and looked up on the frequency table to get the oscillation frequency. So, I mean, barring the fact that maybe our frequency table's all messed up, that's a possibility. These are int. Those are int values. That should be fine. Osc frequency is a float, and that's floated. And you are floating. Yeah, it goes from 0 to 4. And then for some reason, mod doesn't do anything, but mod starts to move when frequency gets up in the higher values. 60, 70, 80, 90, 127. Oh, I know why that is. Well, the frequency knob should not be affecting it at all, but the value of mod is limited. I do not know. This is an older version of Arduino. Code folding? Yeah, there we go. There's a frequency for it. Cool. All right. Oh yeah, that makes my comments a little weirder. Well, I'm going to turn it off because I think that'll probably confuse me. I'm too used to it being the other way. All right, so we've got weird values coming out of this thing for oscillation frequency. That's not F, it's just oscillation frequency. But is it only when I'm in this mode? Change modes. Mod is equal to 0 now. Mod does not change. Well, now mod is working. Mod is still dependent on frequency, which it really shouldn't be. Ugh, it's going to be hard for me to look up. Make frequency uses the oscillator frequency. Mod, knob, and CV are taken in, and then they're scaled, and so they should have, you know, good values on that. The value for mod, for some reason, is moving with the frequency. So what is happening there? Mode switch is equal to switch. Button handler, to bounce or fill. Waveform is equal to that. Waveform modu. Mod A, mod B, blah, blah, blah. And that does wavetable, it doesn't do frequency. Moving down further. This one uses the word mod, but there are variations on it. None of that's using the mod, or none of it is populating to the mod. Waveform, mod is equal to constrain mod knob mod CV, 0 to 1023. Mod knob mod CV. If I plug in a voltage, 3 volts, where's my plug? There it is, into volt per octave input. Nothing changes. I plug 3 volts into mod. Mod goes to 0. Okay, so why is the pinout might be messed up? So let's check our pinouts. So mod, is it mod knob and mod CV and frequency CV? I think it is. Let's check all these. Maybe my pinout's messed up. Procedures are functions that do not return anything. They can have arguments. Well, but putting them ahead of the, it's, I don't know. I'm done being confused for the day. Error opening COM4, yeah. Etc., etc., etc. There we go. Open this up, and I got a bunch of data coming in. I didn't use the functions in order to make these the same size. I probably should do that. What the fuck? Why are both of these moving at once, no matter what I do? Wait, what the fuck? Wait a second, what the hell? It's like the frequency knob is not moving. The mod control voltage is moving along with the volt per octave CV. Both CVs are moving in unison. What happened? That shouldn't be happening at all. Did something break? Or did I do something? Yeah, these are moving in unison and they get to negative values. The frequency knob, which is not the frequency knob, is not moving. And then the frequency, well, the knob is acting like the CVs. What the fuck? And the pots are acting like, wait a minute. So if I put this one into, they both are moving in unison. Something weird is happening. Oh, I think it's because the code is actually creating those values, but it's doing both frequencies and both mods as one. You can see those values are the same. And then the CVs are the same. What's going on, man? It's mixing the wrong stuff, I guess. I think it means that one of my pins is different. This is an argument for doing different global variables for everybody, because it seems like some of these are wrong. But we checked them. We had it printing them out, and they all seem to be the right thing, which would mean that somewhere else I'm doing something wrong. So where do we get our analogs? Get analogs. Mod in pot frequency. Frequency knob. Oh, that's wrong. Oh, this is completely wrong. That must have been a cut and paste error. Well, what do we have here? So the frequency knob is freak knob. Well, pot freak. Freak in. Is it pot freak? Is that what we're calling it? It should be freak pot. Yeah, freak pot. Freak mod. Oops, wait, which one was that? That was mod pot. And then mod in, octv in. Okay, so we had the wrong assigns to the, it must have been a cut and paste error. So mod in, no. Mod in, this one's mod pot. And then freak in, freak pot. That was a weird one. So now everything is... What? Wait, you reinstalled the browser and it's still stuck on Comic Sans. Wait, whoa. That should be impossible. What? Did you mean freak CV? No. No. Freak in? Oh, freak pot. Oh, that's octv in. I'm just gonna call that freak in. Freak in. Freak out. Upload. Is this some early April Fool's? No, all my Twitch stuff isn't fine. Proteus! Yeah, thanks, man. Have fun. Have fun betting. No, I think it probably just had registry settings that you didn't wipe. Oops, octv is not declared. Oh, whoops. Mod in freak pot. It's anywhere else. Mode select, octave. Yeah, probably the no button input pull up. Mod in frequency pot. Where are the other ones? I didn't set them all up. Wait a minute. I don't know. I don't know why it works over there. Maybe the microcontroller code is just that friendly to bad programming. There, mod pot, frequency in, mod pot, frequency pot. Try that. I mean, look, if it's different, then you did something, right? Like fonts, I have a full ass computer. I have two that I use on a daily basis, and none of them had the fonts changed to Comic Sans. Oops, this isn't. I need to close this. Listen, Twitch is not in Comic Sans. I have several instances of Twitch open. Let me open up just a regular old... No, you know what? We're going to go incognito. I don't know why I'm doing this IT shit. Incognito. We're going to browse for some porn. Here we go. Front page of porn.com. There it is. Let's see what Tarek's doing. He's not in Comic Sans, I can assure you of that much. Bro, you suck at Val. Watch Major. Bonk. Anyway. Okay, so all of our inputs have now actually been declared. Which pulls into question, how did I get... I guess the code just wasn't fully pulled in. Yeah, frequency knob now goes from 0 to 1024. Mod pot, or rather, yeah, 0, 1022. I get to 1024. And now our CVs should also be separate. So this one's mod CV. There it goes to 200. And here's frequency. There we go. Goes to 200. Okay, so now frequency is still broken. It still works in discrete levels. 0.55, 1.10, right? But at least now mod and, yeah, there's mod as, it seems like the full range available to it, given that there's a control voltage going in there. Okay, so what does that mean for the actual... What's up, Thunder? What does that mean for the actual programs, frequencies, and stuff? Well, since that's still working in very discrete levels, it doesn't really do much. Now, what if I flip to one of the modes that actually had... Dead. Not quite anything doing there. Hey, look at that. We actually have a triangle wave. Triangle man hates person man. They had a fight. Triangle wins. Boop. Some of the modes don't do anything, it seems. Well, the mod does change depending on mode. This one, it seems to be going between 4 and 2.75 and 4.5, which is odd. I think the only one to affect different waveforms is triangle wave, huh? 7. Well, where's my triangle wave? Every time I do this, it has to make a new table too. And the frequency isn't changing at all either. New octave. Now, one of our frequencies was changing organically, but I'm not quite seeing it. Seven, waveform 0, 1, 2, 3, 4. Our waveform 4 for some reason does something. 5, 6, 7, nothing. And then this one, broken. Just straight up broken. So we need to actually, oh, this mod goes between 64 and 127. Shouldn't it go lower than 64? I think it probably should. Oh, 64 is from the CV being at 0. I'm going to do this. Yeah, mod's now at 25. 25 to 127. It still doesn't do anything. Seems to, well, it almost comes in, it almost comes back there. Okay, so we need to figure out what's going on with frequency now. In all likelihood, it's probably something to do with the number types that are going in there. But see that, look, frequency is doing nothing. It's 1.1, 0.55, 1.10. That's it. That's all I get. Strange. Okay, so close this. Let's get rid of all of the excess. Now that we know that our pinouts are good, they may not be scaled quite correctly anymore, but we at least know they're good. So I can take everything up here, comment that out. All right, so we've got our waveform being printed. What's next? Well, we need to figure out where the frequency goes to. So the frequency is being set when we look at the knob and the CV. So we analog read, frequency input, and these come in just fine. We do seem to get 0 to 1024. Was that running in the right direction? Frequency knob is at 0. If I go to the right, I go all the way up to 1024. Yeah. And the mod pot is at 0, and if I go to the right, I go up to 1024. So those are scaled correctly. I mean, we're getting values out of them. It goes up to full range, 0 to 1024. Cool. Cool, cool. Double cool. Triple cool. And then our CVs are both hovering around 515, 512. So I don't have any of those emotes. I don't know what those are. Unless you just walked in and said a bunch of gibberish that nobody would understand outside of Twitch. Make frequency is what's making our oscillation frequency. We are mapping the values to new values, but those are still integers. When we hit up the frequency table, we're hitting it up as an integer anyway, so there's not really much we can do there. Our oscillation freak, 256 times osc freak over qubits, which is just the replacement number, 1 plus octave switch. Octave switch is an integer, but that's fine. That should be fine. We're multiplying oscillation frequency over the number of qubits, and we're multiplying that by 256, and then we're getting our freak out of that. But our freak is a float. Should it be a double? I don't think so. Why is it so discrete? Is our table messed up? That would maybe be the other thing that might be messed up. Mod A, we turned all of those into, oh, float. What the? Since I'm using these as calculation results, they should both be floats. Let's see if that does anything. Let's upload that and see what happens. Although evidenced by our knob printout, I don't think that's going to fix anything, but we'll just see. A little bit of troubleshooting. The more you do this, the better you get at it. Chat is quiet. It is a Thursday. Everybody's tired. The week is long. We've been listening to 600 kilohertz tones. There it is. Let me close that. Where's Twitch? There it is. Okay, cool. We have a good number of viewers, considering how things have been lately. I took tomorrow off. I need a break. I feel that. I feel that in my soul. So, like, you know, we've uploaded, but how about nothing? How about nothing? What about nothing? How's nothing working out for you? What about that one? Yeah, we need to get the output of the knob into discrete steps. It looks like that didn't work. Whatever we did, didn't work. Change our waveform. That one made a little jumpy. That one's doing something. Doing something. I think the frequency is just broken. Yeah, there's that one. That one works, but the frequency is still messing with it. Okay. The sounds of radio silence. That's more like oh, not quite. Never mind. You're right. Okay. Where our thing? What our thing? Mod 0, mode switch, and waveform. Oh, I didn't put frequency in this. We do have some values of mod in some of the different modes, but they're not really doing anything. Okay, so I need to put in freak. Freak. Oh, are some of our waveform tables not in the right types? That might be too. But freak doesn't operate on a wavetable, does it? Freak. Where are we setting up freak? Make freak. Int. Knobbed. Map. Frequency knob. 0 to 1024 to 0 to 127. Int. Map. Am I using the map function wrong? The meaning of life summed up in code, as in getting the output of the knob to where it needs to go. It's everything, yeah. Map. Variable, low, high, low, or whatever. Value from, to. So maybe if I mix up my from to's, I think maybe that might help save it. If I do, well, no, this is fine. 0 to 1024 is the original scale. Aw, petition. Dun, 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 dun. To force Fadanon to change their name to Freaking-On. Yeah, it's actually. You should probably do that. Map only does integers. That's all it needs to do. But here I have, so instead it would be 1024 to 0. So let's make sure that the mod CV seems to be coming in fine though. That one seemed to be okay, but maybe, I don't know, maybe this will fix it. So 1024 to 0. And this one, 10, no, that one's fine. And then we go 1014, and this one's 1. And then this one goes from 1024 to 0. And this one goes from 1010 and 2. I don't know if it, that might help. Let's see. I mean, the CVs seem to come in smoothly though, so I don't know. I don't know if that's it. We're just looking at it piece by piece. We'll get there. We are looking up a value on the frequency table, so if the frequency table is messed up, maybe that's doing something. Might be that the freak table's messed up. Oh, did I screw it up? I think I did. No, didn't screw it up. Okay. Now 0.55, and then we've got, for mod, half of it works. But it seems to go up as I go backwards. 543210, huh? That's an odd one. But that's only for this mode. I mean, the different modes have different values. So 60, 80 to 127. Yeah, there we go. 64 to 127, I think is proper. So that math is fine. It's just the frequency math is messed up. We only get 2 values out of it. 0.55 and whatever the other one was. I need to update my insulin pump software soon. That'll be a thing. Control S, and then we'll take a look at what we can do with the, I mean, I can do a serial print inside of the things, inside the functions to see what's happening. 0 to 1024, 0 to 127, 0 to 1024, 0 to octave scale. That's the knob and the voltage, and then oscillation frequency. So I can do, we do print line. We'll make it on a, it'll be on a different line. And then we'll just do the osc freak and just see what it is. All we're doing is adding up those two numbers, so. Yeah, let's try that. Takes a little bit to compile. That's kind of a setback. I wonder if the new versions of Arduino are, they're probably faster, right? Waiting, waiting. Flashing. Wrote. Bonk. Oh boy, does that make it a little jarring. 140. 280. 140. 280. So whatever it's looking up on that thing, 140, 280, 140, 280. What's going on there? Are we missing a loop when we create the table value? It only makes 140 or 280. I mean, I don't think that should be a float, because those will be positive values, and we're adding them up together. So it shouldn't be two values, it should be a whole range. We'll check. It's going to be a mad output, but whatever. Boop, 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 boop. We're getting to the bottom of this thing. We're going to root out functionality from all of this dysfunction. It's down to types and little bits of the logic. Whoops. Okay, 127, 612. Oh, there's that nice range. 0 to 127. There's 0, blah, 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 127. This one's at 612, and if I plug something into it, it goes down to 240. Okay, so that makes sense, although I am putting a positive voltage in it and it's going the opposite direction. So I think my flippers are not working, but those are appropriate values. So it's wherever we're making the frequency table that things are screwing up. So now we go to make freak. I go to make freak now. What do we do to do that? That would be table setup. Oct setup. I use the new Arduino IDE. Everyone gripes about it, but I haven't had any trouble. I just use this because it's the accessible one, but I haven't tried the new one. I'm scared of it. I'm scared. I'm set in my ways. I'm an old man. For octave setup, I is equal to 0. I is less than the octave resolution, I++. What that should be less than or equal. The frequency table of I is equal to F0, which apparently is set to 35 right now, times 2 to the number of octaves times I over the octave resolution. That's from I is equal to 0 to I is less than the resolution. Then above the resolution, freak SZ. 2048. That's the size of the frequency table. Minus octave resolution. So 0 to I is less than this minus however many octaves we have, I++. We're subtracting it from it. Frequency table of I plus octave resolution is equal to the number 6, basically. This is a weird way to do it, but what we're doing is we're iterating through I all the way until the end of the, I mean, it might as well have just taken it from a value to a value. Like for I is equal to octave resolution, I is less than the frequency size I++. Why wouldn't you do it this way? Wait a minute. wait a second. What the fuck? That's so weird. That's all of this code. Because now it's just taking it until just before the end of that table. It should probably be less than or equal to. No, it's less than because that table's number of entries. So yeah, from I is equal to 0 to I is less than the octave resolution. We'll start at the octave resolution here, and then we'll go all the way up until the last value of the table. Why was it coded the other way? It's so weird. It's like, did you try to save us cycles by counting smaller numbers? And then it's just frequency table of I is equal to the number of octaves, is equal to the number 6. So from 0 to the resolution steps, we're I++ing through it, and we're doing F0 times frequency table of I. What are you? What are you? Freak table of I. Freak table of frequency size, float. Wave table is an int. Should wave table be an int? Mod 2 wave table is an int. Well, because that's a PWM output. I think that has to be an int. There's no decimals in that. Oh, why is everything dumb? Float osc freak. Int slice number, int k, that's fine. Float is f. F is a float, yeah, that's fine. So why is it coming in weird? That's making the frequency. F is equal to f plus osc freak. If f is greater than 255, it's equal to 0. We limit that down. For some reason we're adding 511 to it here. I am confused. So we take frequency knob and the frequency CV, those are coming in all right. We scale them. Then we take the frequency table value of the two of these added up, which one is from 0 to 127, the other is 0 to 1024. 8, 9, 10, 11, like 1030 something entries. It's going to be tough to get to the lower values of that, but still, 256 multiplied by octave, blah, 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 qubits, etc. I mean, like, by all means, I'm going to upload this and just see what we get again. These are very confusing. I don't know why these values are so difficult to wrangle. I mean, we got the RP2040 sitting right here, so if I knew the original like the original scales, then I could go in there and just make code that I know that would do that scale. But we've got weird like math going on with this thing in order to reference big tables of values. Same problem, isn't it? Yep, 0.55, 1.1. Mod, of course, still works, goes from 64 to 127 positively by going from left to right. That's fine. Frequency is fucked. So what's going on here? What if I put a CV into the CV in, and then I move the frequency? Oh, so now the knob does nothing. It's like it's in discrete bins, but it's been spread out over a huge area. Let's look at Hajiwa's original code and just see what we can glean off of this, because there might be something going on with that. I might have messed something up. Might have, because I'm perfect in every way. Hajiwa code, all the way down here. I hear a puppy upstairs. So let's see, what are we doing? Well, we have Voct POW, which is a totally different thing. And then we have a freak table, which is a float, and it has 2048 entries. Freak size is 2048. I don't know about 35 for F0. I don't know if that's the right number, but we haven't gotten into that yet. We're still trying to make the waveforms. So F0, which is 35, power of 2 times oct pow of I. Voct pow, rather. And that's all of our octaves, but these are linearly scaled, and so our equation should be making them. Maybe our equation's messing up. Maybe something's going wrong with that. 0 to 20. Oh, I see. This is, yeah, 2048 minus 230. Why don't you just make 2048 minus 1230 and then I plus 1230? You're subtracting and adding 1230. You don't need to do that. You can just start at your number, 1230. And he's just maxing it out to equal to 6. We haven't even gotten there yet. Something's going on with our equation. That's what it seems like here. Our table is filled with bogus values, and it's because whatever we're doing when we do the setup is not populating it properly. And so we are still getting float values in that table. The table's full of floats, and it should be. It's fine that it is. Right. Voct POW is different. And we haven't made it yet. Wait, is our table only 256 entries? Hold on a second. Wavetable, mod 2 wavetable, and that. It's the Voct POW is equal to, okay, in setup we do table set and oct setup. Oct setup, frequency table of I, freak table. What is the size of our freak table? It's 2048, okay. And so down here we're setting up our freak table. Now that's where we're using it. Where are we setting it up? That's here. Frequency table of I until our resolution F0 times power of 2 to the number of octaves, which is 6, times I over octave resolution. Do I need to incorporate more parentheses in here, or maybe this is not able to do the math properly? Oh, no, wait, there's nothing to that equation. Hey, Big Gizmo. Octres. 1230. 1230. Number of octaves should be 6. Double check it. Yeah, number of octaves is 6. So yeah, int division. Ooh, okay, yep. So because the compiler sees them as ints, treats them differently. Octave resolution is going to be used in a lot of loops, though. Oh, you cast the int I into a float. Well, if I do 6.0, will that make the rest of them floats? I think it might. Let's check. Let's check what happens, and we'll change it accordingly. Come on, buddy. There we go. Check this. Oh, oops. I keep not waiting for it to actually program. I'm glad it doesn't explode when I do that. Well, now frequency seems to be moving a little bit. Ha! Now our range is not what we would expect it to be, but it does look like frequency does now have a nice floaty value. So you guys are right, it was integer math that went into it. And mod, of course, moves to 127. I don't know why this is the number, though, for frequency control. What does that do to some of the modes where we actually have waves in it? Ooh, that's smooth. That's smoothie. Not a very big range, though. We're going from 854 hertz down to 555. 5 to 800 hertz is not an incredible amount of range. So something's going on with the math. And of course, our mode doesn't seem to matter either. This is waveform 2, 3, 4. 4 is a little different. Still does the same shit. We're getting there, though. Mod seems to be going backwards on this one. 5, 6, and 7. They all look the same. And mod does nothing. And this is an AM, so then we switch to FM. Waveform 7, 0. Something weird. What does mod do to this one? Nada. Frequency? Frequency changes a little bit. Waveform 1, 2, 3, 4, 5, 6, and 7. Nothing. And then we go down to... Actually, wait, it should be FM, AM. Whoa! Oh, that's a sawtooth. I ever done see one. That's gotta sound funky. So waveform 0, waveform 1. That's a nice little AM. What does this do? Doesn't appear to do anything. Frequency does change the frequency, but it's very slight. 2, 3, 4, 5, 6, 7. Jeez, there's just no helping this thing. So yeah, in the reflection mode, everything seems to be kind of in a weird state. Whoops. In a weird state where I can't get anything out. And if I do... Yeah, it doesn't really change much. That don't impress me much. That one we can, of course, do a little bit of frequency editing on it. We can change octaves too. Low octave, middle octave, high octave. High octave. All right, so in terms of the range of values coming in from the control voltages, I'm not sure what to do about that yet. Now, the trouble we're having is with wave folding. So if we are in wave fold mode, go down here, we read the analogs, we read the switch, we read the button, set the table, make the frequency. So when we set the table, we go down here and we look, hey, we're in wave folding mode. Let's make sure that the switch is actually, wave folding mode is 2, waveform 0, mod is at 70, frequency is at 2. So yeah, that's correct. So wave folding, case 2, we go over to WF. WF here. Then we add up the two, the knob of the CV, and we constrain it to 0 to 1023, and then we divide it by 8. So that would explain why it goes from 64 to 127. Because one of them is at neutral, and the other one goes from 0 to max. Well, it only 64 all the way up to 127. I guess that makes sense. We're dividing it by 8. So if the debouncer fell, then we create our waveform. Assuming that we make our waveform. Although, I wonder, those are defaults though. It has two values for default. Sometimes I give it one, sometimes I don't. And they're all integers, even though I've cast them as floats. So that seems to be, I mean, our wavetable may be getting made, it may not be. Let's take a look at saw. Saw is right down here. Zero to 256, the wavetable value of I is equal to I times 4 minus 512. So that's just a very simple equation that it goes through and it creates that wavetable. And so that wavetable of values from 0 to 256 in the entries, 0 times 0, 1 times 4 minus 512, so it's going to be a big negative number. But they're still numbers, they're still ints, they're negative ints. And so we go back up here and let's say we've made that, or no, we're all the way up here. We've made that saw, and we've broken out of our switch case, and that dumps us down here, out of the debouncer. The bouncer still has fallen, but now we calculate the mod wavetable, and the mod wavetable is going to equal to mod underscore wavetable of I times mod. That's 0 to 256 rounds. Normal old microcontroller stuff. None of this is controversial. So mod wavetable is now populated with the value of that saw wave times the mod. So I mean, it really should be like how high and low it is or something, the volume of it, because it's supposed to wrap around when it gets too big. It is obviously not doing any of that. So we need to figure out what is going wrong. So this code is mostly unaltered from Hajiwo's stuff. Mod wavetable of I is greater than 511 or less than 1023 plus 512. Sorry, and mod 2 wavetable is equal to 1024 minus 5 mod wavetable of I. I don't see what could be messing up here because this code is directly from Hajiwo. Hajiwo. I don't know how to pronounce it. Huh. Are my default values messing up? These are not default values. This one does. But then there's no output from this either. So mod is equal to constrain mod CV mod knob 1023 over 8. Should that be a float? Where's my serial monitor? Should that maybe be a float? Well, actually, it's coming in as 0.00, so I guess it is already a float. Although I'm not getting float values on this, but still, I mean, it's discrete values, but they're still okay. I mean, assuming that the debouncer never fell, I could press it again. No, it still doesn't work. Yeah, I'm still running through the waveforms and nothing's changing. Oh, jeez. Willow's buddies are out there. She's starting to bark at them. Oh, wow, it's already 5 o'clock. I've been so excited about this thing working that I'm going a little later than usual. I kind of owed it to you guys after finishing early before. Plus, we've made huge progress. We've gotten stuff to actually start working. So these are setting wavetable, just regular old mod wavetable. Wavetable of I, wavetable of I, wavetable of I. And then if I do this one, it is setting wavetable of I. So that should be totally fine. So we come down here and we do the rounds on that and we make mod wavetable. And then we take mod wavetable and we make mod 2 wavetable. Kind of feels like we should do this once and not have to populate a different wavetable that we never use. It's only there for calculative purposes. Seems like we should just be calculating the wavetable value every single time from this equation. Mod wavetable of I is, I guess this is what gives us our discrete values though. 0 to 256, if it's greater than 511 And wait, so these aren't, oh, these are the values of the output. Oh, I see. Okay. Yeah. So if the values of the output are within those ranges. And then we do also have an else. We just make it equal to the same thing. So we're taking the values of that and we're restricting them. And I guess, yeah, I guess I could put like a mod tracker on this too to make sure that it doesn't, because it's overwriting the table every single loop. It seems a little strange. But I guess that's all right. It overwrites the loop. If the bouncer fell, it's going to make a new wave table. Otherwise, it's just going to use the same wave table over and over. So that should be fine. It'll use the same wave table over and over, but every single time it is overwriting mod wave table with mod. And then if it does that, then I should probably store an old value of these different variables, just so that I can, like, for instance, as it is right now, it's overwriting stuff, but I'm not telling it to do different things. That seems like a bit of a faux pas. You know, something is happening here. Wait a minute. Let's check out pin 2. Is it just happening at a frequency that we can't observe? No, it doesn't look like it. Oh, I'm not looking at the right one. Hold on. Yeah, there it is. Okay, so there's our waveform. Define I as an int in the for loop. Oh, because it's not I and J you reserve for performing the tasks of loops, and so you don't declare them as like global variables. So we define I in here, and then the microcontroller, when it goes into this loop, says, okay, here's memory for that I number. And then when we get out of it, we don't have to worry about I being something weird when we get into a new loop and we use I again. So you keep it within the scope of this for loop. I can't use I outside of the for loop. If I write any other code and I'm like, hey, let's make I equal to 250, then that I is going to not be declared, and it'll come up as an error. And that'll help you, if you're always programming in the same way, that'll actually help you find errors in your code. So what's going to happen is say I was not declared within the scope. You keep your I's and your J's to your loops. Come on, just give me the error. Give me the error. Give me the error. Give me the error. Bonk, I was not declared in this scope. You keep that way, and so if it comes up anywhere else, you know something weird is going on. Okay, so we have our PWM viewed. Mod ain't do nothing. Frequency is slightly adjustable, not as much as I'd like it to be. None of the modes seem to do anything. Why do the modes seem to not do anything? That's what I'm wondering about. Well, there's a little something going on. Trigger me timbers. There you go. This is the only behavior. It's like a binary number. Oh, look at that. It does expand a little bit. Okay, all right. So it seems like it's way too high frequency or something. Or it's cramming it all into one end. Because that is something. Ain't that something? Oh, did this adjust vertically? What happened there? Why is it at like 4 point something something? I must have turned on fine adjust or something. What the hell's going on there? What mode are we in? We are in mode switch is at 2, waveform is at 3. Mode switch is at 2, which is Yeah, this is wave folding mode. So wave folding mode is coming up with numbers that are strange. I don't understand how it could do that, because it's looking for particular values and it's reflecting. So the numbers going in may be bad, but we've constrained that to 0 to 1024 over 8, and it appears to... Well, let's, yeah, double check Hajiwa's code. Double check Hajiwa's code. I lost sight of that. Let's go back to that. We'll take a break until tomorrow soon. We've been at it pretty hard today. We've gotten a lot of really good progress here. So instead of looking it up, we're calculating the table. That table's used just about everywhere. It appears to be working for some of them. For wave folding, it appears to not be working. So what else could be happening here? Because I feel like this table is happening just fine. Although the equation that we got for it, we changed it from the frequency table from integer math. Maybe we've still got a little bit of integer math issue here. Oh no, but the number of octaves we changed. That's not, okay, that should be fine. I don't know if I need to like add parentheses in order to make things calculate properly. Where is that function? A lot of like trigonometry. Where is my setup function for this? Frequency table of I, F0 times the power 2 to the number of octaves times I over the octave resolution. It's going to start with 0. 0 over 1230. And as it multiplies through, it's going to become big number over 6. Is that really how it should be working? 35 times 2 to the 0, 1, 2, 3, 4. Number of octaves times I over the resolution. So number of octaves times I over the... I don't know if that equation quite does what we think it does. Number of octaves, 6, times I over... is it 1225, I guess? Guess that works. But it should do a range of values from 0 to that number over that resolution, I think. And then those would be the available frequencies to us, right? Frequency table 536. Yeah, so up to that resolution, and then at that resolution, it should equal to 6. So it'd be, oh, but it would be 6 times 35? Eh. Our base oscillator frequency is supposedly 35 in, what is it? In the RP2040. 35 times 2 to the, and then that table starts at 0 and goes all the way to waiting to get to the end, all the way to 6. It goes a little over 6, but it goes all the way to 6. 0 to 6, and multiply that by 35. So if we want to generate this linear table from 0 to 6, we need, so let's check if this math is like all it's cracked up to be. Now that I'm getting into the numbers, the wonderful, amazing numbers that we all know and love, We all know and love these numbers, and they've done us well throughout the years. Where the hell? Okay, it's all the way down here. That's right. Because my program is completely disorganized. This is supposed to be just the functionality framework of the rest of everything happening, but I decided to get into the math. And from there, things just went south. So let's see. We've got... There's a setup stuff. There it is. So if number of octaves... So 2 times number of octaves okay, so let's do, I don't know if my calculator is going to really be able to do this, but 2 to the power of stuff is actually a pretty powerful thing in math. It's used a lot in control systems. Use 2e to the something or other. And that like scales it mathematically scales things. So calc. We're going to do this just quickly and see if I can come up with a reason why something is messed up. But I guess we're doing this tomorrow again if I can't figure it out. So this would be, what are we doing? We're doing 6i times 6i and then 1230. So 6 times, let's say 256 over 1230. That's 1.24. So 2... How do I do that? X to the Y to the 1.24878048. Okay, that's too much resolution. 2.44 times 35. 85 point... What does that even mean? What does that even mean? 85.4 is our maximum frequency table value. 85 what? Hertz? So what if it's 1? Then it would be number of octaves, 6 over 1230. 0.004878, which actually lines up with the Hajiwo number. Sounds like a conspiracy theory. 0.004882. 4878, but still 0.04 as our first step. Oh, it's actually going to the 1230. Oh, I did it wrong. Okay, so 1230 times 6 over 1230. What? It goes to the 6? Wait a minute. Number of octaves and octave res. Oh, so it's... Okay. 6 times 1230, and then divided by 1230. Wait, that's just going to give me 6 again. No, 6 times 1230, because that goes up to octave reservoir. Oh, that goes up to there. Yeah, and then that cancels out, and then we have 6. 2 to the 6th. Why can't I do that in my head? 64 times 35? 2,240? What does that even mean? What does that even mean? $35 hertz to 2440 hertz. 2 by 6 to 6 times 35. What? $2,240, 2240 hertz. Okay. Oh, I just got what Ben Gizmo got. Oh, okay. All right. So that's the scale. It should go to 2240, but we don't seem to... This doesn't look like 2240 to me. But it appears that we've made our scale of 0 to 2240, and it starts at a very small... What's the smallest frequency? Well, we'll take 1, so that'll be 6 over 1230. And then we'll do 2. We already did this. Did we do 2 to the 0.048? No, we didn't. 2 to the 2. Do I have to type it in again? 4. Oops. 8, 7, 8. 1. 1 hertz? Oh, times 35. So yeah, 1 times 35 is 35. So 35 all the way up to 2240. That does not seem to be what the range that I'm getting. So this is being created properly, aside from maybe quirks of math. But since we've given it the number of octaves as a float, this should be floating, and it should probably multiply by 35 and go into the freak table, which is an int, I believe. Is freak table a float? It is a float. So it goes into the floaty freak table. So that seems to be fine. And then any entry over our resolution just gets set to the number 6. For some reason, it just gets set to the number 6. So far everything appears to be okay. Boy, I'm really scraping for that number that I have today. It's cool that the number's gone up as time has gone on, but that encourages me to keep streaming, and I got to take my puppy for a walk. So we'll hammer at this for just a couple more minutes, and then I'll call it. What the hell is going on with this code then? Our frequency table should probably be coming through just fine. Wait, why is this printing normally now? Oh, did I get rid of? Yeah, I got rid of the serial prints. So if our freak table's fine, then where's the error? This would be freak table. I should probably write down what happens. Let's go. Let me go back to the equation real quick. Save that. Let me close the serial monitor. Frequency table's okay. The wavefold function isn't. Well, this is taken directly from Hajibo's code. All right. So my wavefold function is WF modu. Mod is equal to constrain to those values, and it's multiplied by decimals. Mod is in float. Mod is already a float. So mod's a float, and we've got decimal values multiplied by the constrain. So mod does have a value to it, although for some reason there are no decimals in mod. What's going on with that? Mod is constrain, mod knob blah 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 divided by 8. Constrain get back here and look at constrain. Constrain, because the constrain function is implemented. Avoid using other functions inside the bracket. It may lead to incorrect results. Int constrain, int constrain. Int. Hey, Mahalo, how's it going? What do you, huh? Oh, if I tell after constrain, if I tell it that it's a float. Oops. You are a float. Because I'm looking it up, and constrain doesn't seem to tell me anything. Although when they use it as an int. It does not appear to be floaty. But if I constrain it after dividing from 0 to 1023, yeah, I guess that might help it out. And then the mod wavetable times mod wavetable and wavetable are both floats. I don't think I have an int table. Let's just see what that does. Strange. Do I still have the serial monitor open? Oh, I do. Close it. I got there just in time. It's going to upload in just a second. All right. Well, that looks different from what we had. Oh, that's different. What about you? No, that one's still weird. Oh, we were way zoomed in though. Wave folding. Not quite my tempo, huh? Oh, that's all messed up. All right, let's look at what our variables are doing then. Oh, you explicit cast. I was thinking about whether or not I should do that, but let's look at the serial prints. Boom. Ah, there we go. There's all our decimals now. So yeah, that was it. You guys got it right on the money. So that fixed the resolution with the mod knob. It didn't fix anything else really. 0.16 to 0.24. The frequency number coming in is a little bit weird. All right, so I don't know if we still, at least insofar as these variables are concerned, I don't see an issue with casting. Oh, well, it might, in some of the other modes, it might still be casting it as a too discrete of a number. I mean, look at that. And then if I switch down to AM mode, AM mode's got it all right, but FM mode has it still discretely. Let's see if we can take a look at that then. Let's look at FM. And then, yeah, 1023 minus constrain. That's still going to be, that's not going to have any decimals in it, even if I do 1023.0. Let's see what that ends up doing. You could reverse, that's weird. I don't know, let's just see what happens. Maybe it fixes some of the math down the line if mod remains with a decimal. Yeah, and explicitly casting stuff would probably be a pretty good idea. It pretty much just like, this should be this. Like, do not mess. Do not come. Uh-oh, I think it uploaded and I still told it to... Oh, by the way, it's also, I think it's remembering the mode that it used to be in. Let's see if it's in a different mode when I boot it up. That might be something that I need to fix, I'm not sure. The waveform mode should be saving in between, but I may have set it to not save in between power-ups. Yeah, because it's starting at waveform mode 0. And if I go waveform 3, and then we power it down. Oh, but I'm going to have to... Okay, that'll stop serial. This will power it down. Then I power it back up. Put serial back in. We'll start up the port again. No, wait a minute! What did I just do? I think I just closed what we were working on. I did. Oh, good thing it just saved. Jeez. Getting a little too crazy with my... It didn't save. It didn't save because I'm actually giving it a value at the very beginning of the code, which is not what I should be doing. I should be getting rid of this. So waveform is equal to... Well, this is where it reads it in from the EEPROM. Waveform is equal to 0 and previous is equal to 9. Oh, this is what's nuking it. I see. Oh, no, wait, that shouldn't be... So I guess once we read it in, I need to set the previous to the current. There, that'll do it. So instead of what basically I was doing this because in case there was a number that was over, that was too big, but it left in the EEPROM memory. I'm just going to trust, because it'll be F. It'll be whatever the maximum integer is if you read it like that. So the first time you boot, it'll be a maximum number. But since then, we've changed waveforms and we've overwritten that slot. On the very first boot of a very first program of the device, I'll have to comment that out. Okay, so we can take a look at our numbers. Or not. Oh, there's already one running? Huh? No, there's not one running. What's going on? Why are we erroring out? Well, it's still adjustable. Why are you having troubles? Port. COM4, Raspberry Pi Pico. Start the thing. Why is the thing not starting? Wait a second. I'll save and I'll wait for it to save and we'll see if we can open it up. Okay, that's running again. What the heck? I don't understand. I don't have the monitor open. Strange. All right. Well, anyway, my brain is turning into mush, so I think we're gonna leave it where we have it. We still have some stuff to work out. Let's see what we've got going on here. Mod does nothing. Frequency does adjust. It just doesn't do a lot of adjusting. I don't really see that range. We're at 80 hertz. Shouldn't we be at 35? And then we go all the way up. We're at 123. But we should be at 2240, I guess. So our range is, something's going on with that. Probably based on how it's doing its math. This is, of course, AM modulation with FM modulation. Nothing happens, and none of our modes do anything. Or sorry, this is waveform. This is FM. FM works. AM, well, it seems to be doing something. Although mod isn't doing anything, so I fear for the math. That's a cool looking waveform though. Next. 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 Yeah. So if I weigh up the frequency, I mean, it should be more visible what it's doing, although it appears as if something else is completely busted now. More of the math probably screwing up. Oh yeah, take this out. There we go. I guess I was lowering the frequency. Why don't we have like no control of this thing? I guess I was on a low octave too. Still, mod is doing nothing. Nothing. Next to nothing. Let's go back to the wave folding. Nothing. Something weird is going on with our math. Okay, so we got to resolve all the mathematical equations on this thing. Our hardware is good. Our software is mostly good except for the LED indicator, which we didn't code. It's just our math we now need to kind of wrestle. We need to wrestle the math into submission so that it works for us. We can do that with serial prints. We can continue to monitor what the outputs are and what things are being set to so that we can see if our numbers are in the right ranges. That'll get us really into how this thing functions. And I guess, yeah, classic math, what a kidder. Yeah, math is just pain. Well, I'm going to try to be a little bit more awake tomorrow so that I can actually do math. It's stupid things with microcontrollers and programming, like the fact that if you have a function that has values put into it, it needs to be declared before the thing that calls on that function, whereas if you just have routines which have no numbers in them, they're just things that happen, they can be below where they're called. Is that a thing? I guess that's a thing. It's a thing chat corrected me on, and when I moved my function, things worked. So it must have been causing problems in the past, those times when I had to move stuff and I didn't know why it worked or not. That's a new thing that I learned today. So I'm learning, you're learning. I hope everybody had fun today. You guys can catch me on Discord when I'm not around. All three of you that are in chat. It was nice having you, but here is the end card, all the stuff you need to know. I'm gonna be back tomorrow. We're gonna be working on this still, just because I gotta get it done. Dave and Julian wanna come in here at some point. I want to make sure that I'm able to build them a couple of these modules to give. But once we get this one working, that will be the springboard into the chord VCO, and we'll have to figure out how in the hell we're going to do chords. I have no idea how that's going to work. That'll be fun though, and I'll catch you guys then. Until then, I don't know. Catch me on Discord.